Morning.
Morning.
10 past.
Morning, good
I
morning.
think we can start, but I have a huge problem this side. I don't know how we are going to work. Let me see. At least until James joins, that is going to be a bit late. How do I switch on? My laptop, I think yesterday it made some updates. Now I can't connect to the internet at all. It says there's no drivers, even with the cable installed. So I think best I can do until James arrives is take you through. You guys will be doing you'll be doing the coding, and I'll just be taking you through it. You'll just copy paste to see on your side instead of me sharing the screen. I apologize about that. I don't know. I can only get it fixed tomorrow. It's the holidays this side, so there's no one who can help me today. We had stopped at names. Names. Can I get a thumbs up if you are at that slide? On the notes on the manual. I'll just share the link for those who haven't opened it. I see one. The others have shared the link. Where we are. When the data structures means we stopped there yesterday. Can I get a thumbs up again? Because I only saw one. 2, 3. So Nancy and Obi, did you guys manage?
I don't understand what you're saying, ma'am.
I was saying I shared the link. We are at names, and then if you had missed it, I said I have a challenge on my side. I don't know what happened. After yesterday some update was running, so today I can't access the Wi-Fi with my laptop. I even tried connecting my Ethernet to the router. It's not picking. It says there's no drivers, so I can't even ask anyone for help because this side we are celebrating independence, so it's the holidays. No one is working. Only tomorrow.
Where are you talking from?
My phone.
No, where are you talking from? You say you are celebrating independence.
Yes, we yesterday we were celebrating 59th of independence in Botswana.
Okay.
Yeah. So today is like a public holiday also, so
yeah,
no one is working. All the technicians are not there.
They've gone to bed. Also, I'm in the names, so we should just be.
Okay, so today is gonna be a bit different. You will be running those to see on your side how it outputs. It should output the same output the nose
Can I come
outputting.
again, ma'am? Can I come again, ma'am? Is the
Yes,
problem from you say you cannot locate the drivers or so? Can you switch it off and reboot the laptop?
I've done that. I've done that. That's why I even connected my Ethernet cable to the router. It's still not picking
Okay, sorry for
because it was
that.
saying no Wi-Fi adapters.
Yeah, maybe there's a crash somewhere.
Yeah, and hopefully I'll get it fixed by tomorrow morning. But I think James should join us. When is it?
Have you
After
communicated
the
to
first
Jenny?
break. I talked to
Okay.
him yesterday. He said he was gonna be a bit late. I should go take over, and then I just said yes because the laptop was still fine yesterday. So my assumption is he's gonna come at the agreed time, but I've communicated. I've sent him an email. When he says it, he should be able to join as quick as he can, and then he can take over. So well, names. With names, we can give meaning to elements. Like I've been saying earlier, we don't just want to have random names. You need to have like meaningful names. And then when you have those names, it's like your columns, right? You want to access them. We are doing accessing vectors and lists by name. We were accessing them above, we're accessing them by position. So now we are going to access them by names. If you can all copy that pizza price line, the first line. We're gonna create a vector called pizza price. And then after creating that vector, let's say you want to retrieve the value for pizza sub into with the name. You just do pizza price and then quotations, the name you want to retrieve. It should retrieve the value of that. And then that approach where they do pizza price like we're doing above, where we're like yesterday we were like another list and then title, then you retrieve whatever element is there. This time it won't work. Why? Because this is a vector. Remember, a vector is of the same type, right? Unlike a list where it's of any type. Here it won't work because it is a vector. That's why that line where it says the approach used for the list does not work. You will get the same error they have posted there. So it will pay off if you remember this error message, because in the future when you're analyzing data, you might get this error and then you'll be like, but I use the same the right format. Just remember, okay, this is a vector, not a list. So like we were changing using positions above, we can change, you can access and change names using names. So if you do the names function, if you ask the help, what attributes does it take? You can do the help for names, just the attribute names. Someone can unmute and let me know what it takes. the help for names function. Remember, it's a question mark and then names. And then on the side, it should tell you what it takes or what it does.
Yeah, the names listed, the whole names in that Peter Price, but it omitted the numbers associated with each name.
Okay, yes, it's only, you only want the names for those. So we don't want the content. Okay, thank you.
What happened?
Thank you, Melissa. Melissa shared with us because I don't have a screen.
Okay.
Yeah, because I was like, what arguments does the names object take? The function is to get or set the names of an object. Yes, Obi. So unlike earlier where you were using position to get the elements, the names only you only get the names of those functions, which is why it showed you it's like your column names only. And then below, you can run the one below. This one you are using.
Very particular.
Yes?
No, I said the one names Peter Price, then in the list for 3, which that's a particular one in
Yes,
that list.
you are accessing names. When you use names, you are only accessing the names of those columns, not the values, right? And then when you do 3, you only want the name of the third one, which is
Yes.
Pizza. Remember above it was there's only 3 of them. And then now you are saying let's access the third one, which is Pizza.
Mm-hmm.
Yes. So we can edit the names same way we're editing the values above. This way, it's similar to the way you get the name you want to edit, names pizza, and then here they're editing the one at position 3, and then they're calling it pizza. So it's going to replace that pizza without the dashes with the pizza with the dashes. And then when you print pizza price, you will see that it has changed the column name.
Okay.
Yes. So like how we were finding out the type of information contained within the columns, we can find out the type of that column. You can just do type names of, and then it will just tell you what type it is. Alternatively, you can just save it in a variable like they did in N, and then names pizza, and then you just ask the type of that variable. Can we do challenge 4? Instead of changing some of the names, a vector list already has, you can set all the names of an object by writing code like replace all caps text. So can we do that? Create a vector that gives the number for each letter in the alphabet. We know there's 26 alphabets, so 1 to 6. 1 to 26, sorry. And then R has a built-in function called letters. There is a 26-character vector from A to Z. Set the names to the sequence to this 26. So what you do, letter number, you assign it 1 to 6, 1 to 26. So it's basically a sequence, or 1 to 26, 1 dash 26. And then now that you have that letters number, you're gonna do names and then all the letters, all assign them to the built-in function called letters. What you said? The whether it's caps or not, that thing is important, right? If you capitalize, I forgot the word I want to use. Basically,
Be
if you miss, maybe
sensitive.
you write. Yes, it's very thank you. It's case sensitive, so you must write it as it is. If you write small letters in small letters, it's not going to do anything. It's
Sorry,
gonna give you an error.
which challenge is it?
4.
Challenge 4.
Yes.
Okay.
And the names.
All right. That's it.
I know there's a solution, but try doing it without the solution first. Pick in the solution so that you also can see how much you understand so far.
I don't even understand it so well. Name objects. Character vector.
Yes, that's
Okay.
just a sample of what they want to do. And then under where it says create a vector, number 1, it tells you, step 1, generate a vector. You know how to create a vector. You name it letter number, and then you assign it to with the sequence 1, letters 1 to 20. So it's best if you take it step by step. You do step number 1. If you have any problem, just unmute. When you are done, just react with a thumbs up so that I can get the idea of coming. Only one so far. If you have any question, just unmute.
If I understand, it just like we have a later vectors 1 to 20, between 1 and 26. These vectors are, the numbers will be between 1 to 26, and the same numbers will be assigned to letters, capital letters. Is it what it's all about?
Yeah,
Hello,
so it's, yes. Hello, can you hear me?
yeah.
Yes, so it's just saying instead of changing the names, let's say you want to make it letters. Instead of you writing A, B, C, D, assigning those to A, B, C, D, manually typing them. There's an inbuilt function called letters where it automatically picks and then assigns them, because it notices, okay, it is a 26 character vector, and then you're assigning it to those letters.
Okay, so which
Yes.
means these inbuilt letters are the capital letters, ne?
Yes.
Then these vectors we created between 1 to 26, which is the first thing we are told. They say letter, small letter number, which will be from 1 to 26, 1-26, sort of. Then this letter will be assigned to, these numbers will be assigned to the big letters somehow. Is it what we
Yes.
are?
Yes. So you saw earlier we had pizza. We had pizza price, names of pizza price 3, and then we changed it to call a pizza. You can decide, okay, this one names pizza price 3. We want to change it to like a number 1. That's you. It's just a normal heading, right? And then here it's like if you want to maybe generate a list of alphabets, instead of you assigning letters number to A, B, C, D, E with a lot of commas, you can just first assign it to 1 to 26, to a sequence 1 to 26. And then you are like renaming it, reassigning those values, right? Like how we did with the call a pizza. And then instead of you having letters, like numbers, you will now have letters. So you can look at the solution below. You
Okay,
click that solution to
we
challenge.
named the numbers, the vector we have created, like we named the vectors we have created to be within
1 to
the
26.
capital letters. Then we can print the letters somehow. The small letters. Let me try it. Let me see what
There's a solution just below. You can just click that and then copy paste. You'll see the output on your side.
Okay. But let me try what I was saying, and let me know whether I will get the same thing.
Okay.
Yeah, I got what I was saying.
Okay.
You know what I did? I got the vectors, the little number, letter number 1 to is equals to less than 1 to 26. Then I named
Yes.
this number that it should be equal to the capital letters. Then
Yes.
then the next line I said letter numbers, that the letter numbers. Then
Yes.
he gave me every letter that's a number underneath it between 1 to 26, and it's one A to Z.
Yes, because you just
They
did
are
letter
put.
number before.
Yes.
Okay. Yeah,
That's what.
then it's there. Okay, then let's continue to data frames. We have data frames at the very beginning of this lesson. That cats, when we did it, that was a data frame. They represent a table of data. I don't know, do you still have cats on your environment?
I think so. I still have mine.
Sorry, before we go far, I'm lost. How did
Yes.
with B? How
Mm-hmm.
I can do. Okay, I
how
can share
did
the screen.
B
Okay.
be? Is it that B is equals to 2 with the letters?
Is it that?
B is equals to 2 from the sequence.
Yes. Yes.
Can I
How did
answer
it
you, my
assign
brother?
itself to?
Can I answer? Can
Ye-
I help you in that thing, my brother? Because that B was a bit confusing me. I will suggest to
Okay,
you, remove
okay.
that B, and just write later numbers and let the result come out. Then you find out
Mm,
that the letter B, 2 is under it. The numbers have the letters have corresponding numbers on it. But if you just want to pick a particular one out of it, you can say
mm.
letter K. It will give you the value for K. You
Oh,
say and it will come. First of all, to be on the safe side, right? Just run the letter number. Then it will
mm,
give you the whole letters and the numbers. Then you can pick any
mm.
one that you want. Maybe you are looking for.
Okay.
Try it and see whether you
Yeah,
will get it. Did you get it?
yeah, I get it. Yeah,
Yes. Then you see that that letter B is 2 is under it.
yeah.
Yeah.
Thank you very much.
You're welcome.
Okay, thank you.
You're welcome.
Do you still have cats? Because if we don't, I think we'll have to create it again,
I still
which
have my
is
cats.
anyone who doesn't have cats. Okay, it looks like everyone has the cats. Let's continue. So I think we all did. We also check if you are cats. You did convert this to true or false. The true logical. The likes catnip.
Yeah. The cat like catnip has true, false, true.
Okay, that's good. So if you do types of cats, you will see that it's a list. Remember, you are doing types of cats, so that whole thing is a list because it contains code being uh code being strings, weight being doubles, and likes catnip being logical values. A data frame is like a list of vectors. Vectors, remember, they are of the same type, as you can see. and they must have the same length. So if you have coat and then you can undercoat, you cannot have tabby and black, and then underweight you have all the three weights with the minimum value for the third cat. So all of them must be of the same length. So if you do class question mark, what do you get? So the question mark class. Yes?
What do you say? If we do?
I'm sorry, I can't hear.
You said if we do cats,
Question mark class.
that's on that class cat or just okay.
Just
Question
class, like
mark class.
the
Okay.
class, so that
Okay.
it just tells you what it does. Because the function, it should tell us how the object is constructed in the computer. It should be a bit similar to type of, but this one tells us more. You can do question mark class and then do question mark type of, and then you can see a bit different. Okay, in our class example, we have, they're saying an integer. I think they meant to say a string, a double, and a logical variable. As we have seen, each column in the data frame is a vector. The whole thing, cats, is a list. And then the columns, they are vectors. So you can do cats code. It should give everything there. And then it's the same as doing cats, comma, 1. You can play around with that. You do cats, comma, 2. Let's see what it does. Hi, Dockers. I think you just joined. I have a problem with my computer, so please bear with us before, like, until the next break. James is supposed to join, so they can take over. I'm not sharing currently. We are viewing the notes from the material. Maybe I can ask someone to share their screen. Mudisa, if you don't mind, would you share your screen so that we work on it together?
Oh, hi. What do you need? The screen. Do you need like fuck?
So that as we go through, everyone, even I can see your screen.
Hold on. Okay.
If that's okay with you.
Let's do this.
You can choose just to share the R window, not the entire screen.
Sure.
Yes.
We're gonna say. Okay. Is it the one? No. Fuck. Okay. we read them.
Click on the screen you want to share. Can you?
Okay, just a minute. Yeah. Is it good?
I see it.
Okay.
Dorcas.
Try again.
Dorcas, were you also trying to share?
No.
If you can't, someone else can.
Okay, no, somebody should try that.
What exactly do you want us to share?
I would like if someone shared their RStudio screen. They can just share the RStudio screen. Or we can just continue. Okay.
I see mine.
Yes, yes, I can. But you can just choose to share the. But I think it's fine. We can continue. So
Are you okay? Are you okay with mine? I should
yes, I
stop it.
can see it. I can see it. It's fine.
Okay.
That's yeah. So if we do codes, CATS code, we will get a list of all the codes, right? And then you can, instead of drawing CATS and mentioning the column name, you can use the position, right? If you do CATS, 1, you will get that. You can do CATS, 1, and then also do CATS, 2, so that you see the difference. For B. Yeah, I don't know if your screen is frozen or.
Am I doing the right thing?
That's what I'm
Is it?
saying. I don't see you moving anything.
Okay.
I just see this. Does everyone see the same thing I'm seeing from my screen?
When I wrote cats, did you see my cat? Because
I don't see you writing anything.
No, we see the Zoom
Yeah.
window.
only the Zoom.
Yes,
You're
that's
not
what we
seeing
see.
my R-code screen.
No, we are not.
Okay, let me stop it and see.
Maybe just share the R window. If you go share and then choose which window you want to share. Only the R one should be fine.
I don't know how to share it on our Windows tools. Let me check. No, I cannot. Only that, unless I copy what I did and paste in the.
Okay, no, it's fine. I think
Okay.
I'm looking at the notes and everyone else is doing. My question is, are we all getting the same thing? Then it's fine. You do code, you should get the names of the cats, and then you do cats, one. You should also access
Cats,
those
one.
names.
I got an error sign.
And it's saying
Cats,
like
one. Is it
the
one
the
in
one
what
like
way?
the one like brackets and then one, like the one on the manual.
Okay.
It's
Okay.
cats and then brackets,
Okay.
one. Is it fine now?
Mm.
Mhm.
I think it
You
should be
can try
okay.
with cats, 2, yeah?
Okay, this arrow side, just because it's a list, ne?
Yes.
Cat is a list.
Yes.
That's why we
It's a
have this
list of vectors.
square brackets in it.
Yes, cat is a list of vectors. The data frame cats we created is a list, and then code is a vector. What else is there? Weight is a vector. That's why we can access it using this, because it's a list. So if you do cats, brackets, true, what do you get?
Got the numbers.
Which are the
2.1,
weight?
the weight of the of the
If you
of the
if you
of
do
the
cats, 5.
the 5 or
Mm-hmm.
Hello.
Hello?
I'm sorry to disturb. Yesterday evening I was working on something, so it seems like I lost cats.
Oh, okay. I
Yeah.
think cats, you can create it again. I'm on my phone, so navigating is kind of hard. I'm not sure if it's the first. It's on the previous letter. Oh, it's at the very top. You can create it again on the same data structures. You can create cats.
Yeah.
Yeah. And then in case we're gonna need it, you can just do those first 3 lines, 3 codes at the top. You can save it in a. Did you save it yesterday?
Mm-mm.
Oh, okay. So you
No.
can just quickly go to the top, copy paste, create cats, save it in a file, and then we also changed the logical values. Instead of 1 and 0, we changed them to true. I will look for the command for that, and then you can also
Oh, I work on the console, ne?
on the R, yes, on the console.
Okay,
yeah,
thank
there's
you.
no cat car, 5 because there's no column 5.
Yes, so it should also always warn you the data you're trying to access is not there, right?
Yeah. Undefined
Yes.
column selected.
Yes. Mm. So same way you are doing type of cats $sign code, you can find out the type of cats using cats brackets comma 1, right? You can
On what?
also,
Use it on
isn't it earlier, like yesterday we were finding out what type of uh vector is codes. You were using type of and then cats $ code. This time you find out using type cats comma 1, the with the brackets, and then it should list, or you can use the str, which also tells us the type and the length and the list the name of those values.
So what I can see that cat code, $code is the same thing as cat comma 1.
Yes, because you are accessing, it's in the first column, and then the comma 1, it's space comma 1, right? You are accessing the first
That the
column.
cat, okay.
So those boxes, the first space is for rows, the other one is for column.
Yeah.
If you leave it empty, it means you want to access everything in column 1. I
Okay,
think
so
if
if
you can do cat 1 comma 1 and then see what it prints.
okay, let me write cat weight, and see
You
what
can
it will
do.
give me. Dollar
You
weight.
can.
Yeah, it's okay. I
Okay.
wrote cat dollar weight. It gave me the
The
weight.
list of the weights.
Yeah.
So it's the same as doing, if you want to access it, because it's in position 2, it's in the
Yeah.
second column, you can do cats bracket comma 2.
2. Yes, they are the same.
Yes. And then if you want to access, let's say, black in cats, the name for code, what do you do for black? You can just do cats 1 comma 1 and then see, because I'm saying, the other one is for the row, the other one is for the column. If you leave it empty, it means you want to access everything in that.
If I should
You want
write
to
cat
access everything in that row.
1 comma 1.
What do you get?
Let me see. Yeah, it gave me calico.
Yes, because this is about position, right? It's saying in
Yeah.
row 1, column 1.
Column 1.
Remember,
Yeah.
it's row, column. So if you
Yeah.
want to list everything, you leave it empty. You leave it empty. So if you do cats comma cats brackets with empty without numbers, what do you get? Without any, just a comma in between.
Okay, let me try it.
Space comma space with the brackets.
It gave me everything.
Yes, because cats is a list. So if you do comma without anything, it should print everything. If you do if you leave the space, it means give me everything in the rows. Give me everything in the columns.
List. Yes, everything in the list.
Yeah, so because there, like I'm saying, the first space is for rows, the second is for columns. So depending on what you want to access, you can do it. So if you do cats 1 comma space, it should give you everything in the first row.
If I put
Cats 1 comma with the brackets, cats 1 comma space, it should give you the whole row. Because remember, the first one you are mentioning a row, second one a column.
Yeah, it gave me row 1.
Yes. So if you do type of and then cats space comma 1 and then below do type of cats 1 comma space, let me know what you get. Do for both.
Type
Do for
of
1 comma.
cats.
1 comma space, and then do type of cats space comma 1, so that you see them side by side like you would see. Is it a type of gives you what type of
It gave
element
me
you're looking
character.
at? For 1 comma, for space comma 1, right?
Yeah.
Now do same thing, but for 1 comma space.
Okay. List.
Yes, because like I've been saying, a cat is a list of vectors. So you have those cats. Cats have code, weight, likes. Those are all different types of data. That's why it makes cats a list. But if cat had like all of them being strings, it will also be a vector. But because it's a different kind of vectors, they make a list, and then those vectors, because they're of the same type, that's why they are a vector. So if you can just copy that one, str cats 1 comma space, and then do same for space comma 1, and then see the difference between the two.
The string
Also
on strings.
str and then space
What
brackets
does
cats.
that str mean?
It tells you all the details
Yeah.
about an element you are looking at. It will tell you what type it is. It will tell you how many elements it has. It will even list those elements.
Yeah, it
Unlike type
listed
of where it just tells you it's a character or whatever.
all the already we know that cats comma cat 0 cat dash comma 1 is their characters. Already up there we saw it. Then the string cat that same dash comma 1, what type is it? Is it a string or a number? That's why it brought out the strings that they are made of, like calico, and they are in bracket black, tabby. These are strings, as I can understand it. And they are on column 1, and they are in row 1, and 3 columns. No, am I correct? Hello?
Yes, it's all of the columns in row 1, because you wanted everything for row 1.
Yes.
So it listed. Okay, let's do challenge 5. This is just to see, like, to get you familiarize yourself with manipulating the lists and the vectors. So you see, if I type cats bracket 1, what do I get? If I type cats bracket 1. So just type those and then see the different outputs it gives you. And then you get comfortable with, okay, if I want to access Calico, I do this. If I want to access black, I do this. If I want to access the true value for Calico, I do this. Oh, okay. Looks like James joined.
Hello. Very
Hi,
sorry for
James.
being late. How is everybody?
We're good. We're good. I've been trying with what I have currently.
Yeah, sorry, I just saw your message about your laptop. Sorry that I didn't see that earlier.
It's no problem.
Yeah. Sinati?
Yes.
My observation is when we type dash str cat space comma 1, we got
Yes.
result as CHR in a list of 1 dash column 3. I think it is showing that in that is it column and what again?
For
The
cats, which one? Cats, 1 comma blank.
row ahead. That row 1, that
Yes.
row 1 has 3 major strings.
No, row 1, which is cats 1 comma space. It has a character, it has a double, it has a logical value, which is code, weight, and legs catnip.
Pardon?
You're asking for str cats 1 comma space, right?
Comma space.
Which
Okay,
you were asking about that one.
The first one, okay, the comma space, the one which I just did now, str cat 1. Then please explain it again for us. Let's see.
Isn't it? I was saying, if this cats is a list, cats is a list. It's a list of vectors, different vectors with different types, which is why it's a list. So if you do cats, and then you are like, okay, I want to access the column for code, which is all the names for code. You do cats, and then you leave a space, meaning the space, if you don't put anything, it means you want to access everything on that row. And then you do comma 1. If you do comma 1, it's gonna give you everything on the first column, which is code. If you want to access everything in weight, it's space, comma, weight, and then it gives you all the figures for space, comma, 2, and then it gives you all the figures for weight. And then if you like, I want the name for Calico, you can do, okay, where's Calico? You look at your data. Calico is at row 1, column 1. You just do cats 1, comma 1, and then you get just the name for the code for Calico, right? So this one, when we do cats 1 comma space, it means we want row 1. Row 1, you get the row 1. And then space, it means we want everything on row 1. So you're gonna get all the columns for row 1, which is why when you do str cats 1 comma space, it tells you, let me start with type. If you do type of cats 1 comma space, it tells you it's a list. Because why? When you print it out, you get Calico 2.1 and true. Those things are a list because they are of different types. And then when you do str cats 1 comma 1, it tells you this thing is a data frame of 3 variables. It has code of this type, and this element, it has weight of this type, and this element, it has like catnip of this type and this element, which is why it's different from cats space comma 1. It's about the position of
the positioning. I did the next line now instead of 1.
Which next
cat.
line?
I just did it on my own.
Oh, okay.
str cat 2 comma space.
2 comma space, it means you want everything on row 2. Everything, all the columns on row 2. So it's gonna row 2. If you go to row 2, it's who? It's black. And then it lists all the attributes of black. If you just want black's name, you're like 2 comma 1, and it's just gonna give you black. So that's why I'm like, you can do challenge 5. You should do challenge 5 to see the different ways if you are gonna get, because it's dealing with just 1. So you do cats 1, cats brackets 1 1, so that you'd see the different outputs you'll get. It's focusing mostly on those, so that you can see, okay, if I want to access this, I do this. Also, you should look at the table to see if it's giving you the right output. Okay, you're like, oh, it's really giving me this, because remember, it's a row column, right? And then you can just look at those. James, we are at challenge number 5 and data frames. I just asked them to do the challenge by themselves so that they can see the difference.
That's actually a really good. Challenge 5 has all the different ways of accessing the data frame.
Yes,
It's going to show you everything about a data frame, basically.
yes.
So that shows that. So do you want me to share and do the final matrices section?
Yes, please. It's kind of hard just being on the phone.
Yeah,
It's
sorry,
not just
you must have
talking.
done amazing to explain this. I guess everybody had to practice a bit more directly as well.
Yes, which is also good for them.
True, it's good to direct practice. Yes, hello. All right.
Yes.
Sorry, hello, Ducky. I'm just doing some work at the moment. You're gonna have to go with mummy. We're sure. Right, sorry, I'm just being interrupted. I'm going to show you. Look, this is the reason why I'm late. This little monster was poorly in the night. Then you Ducky. You were a bit poorly. You want to say hello to everybody? Can you do a big wave? And say good morning.
She looks better.
Yeah, it's amazing. She was like, I know. The reason I was late is because from about midnight to 3 a.m. she was being sick in the night. I don't know if anyone's seen kids being sick. Bed sheets, towels. She's in the toilet in the bucket. She's 2. Anyway, so then this morning we were a bit late getting started. That's why I was late. And now she looks completely fine. She's running around. I can hear her shouting. So that's what the resilience is like for these very young kids. Anyway, okay, cool. Can you see my screen then? You can see my RStudio window.
Yes, we can.
Cool. And I just made the objects for earlier, but we'll start with matrices. So what you've covered so far, Senate, is like some common data structures, and it focuses quite a lot with data frames, right?
Yes. And so far, does anyone have a question on what we've done so far before James continues with matrices?
No, I think we on that card, the challenge 5, we were able to, it just came out in different forms depending, a list in a list. That card, a list, that's a list in a list of that card. First, just a list of cards came out, normally the first one, then it came out in a quote, the names and okay, I have a bracket 1, list 1. It shows the code, the 1, 2, 3, the calico, black and co. But when I said cat, a list of cat in list 1, it wrote it in a different form with commas on as if it's a string in the list. I don't know what I'm communicating. Why should it be?
So all of those in challenge 5, all of the different options, all the different examples access the data in different ways. And I guess they first can access different parts of the data frame, so they can access individual values, rows or columns. And what's also important is that the format of what it returns, it can be different. So it could return a column as a I guess as a list. It could return it as a vector, it's just to show there are different ways of extracting data from data frames. And the reason you would do that is your next step might require a list, or your next step might require a vector. And so being able to pull that out in different formats is useful.
Okay, so that which means it's a vector in a list, and it came out in another way. Maybe I don't know, because instead of coming in a column or under quotes, it came in as if in a column, in a row like that. You know, that was why I was asking. Why should it be?
It's pulling out the data in a different way, and you can always do type of will tell you
Depending
what
on the
kind
way
of
we
data
want
above.
it.
Exactly, and you would want it for different reasons for depending on what you would do next.
Okay, thank you.
So here we're going to go now onto matrices, and I think this is the last data structure we're going to look at in this episode, and then we'll probably have the break, so I've not been here long. We're going to make a matrix is another type of data structure, and it has two dimensions like a data frame, so that means it has rows and columns. And we can make a blank matrix by just typing matrix, that's the function. And then if you type 0, then it means all values will be 0, and we want there to be 6 columns and 3 rows. So if you show that now, so we've made this matrix. It's called matrix example. All the values are 0. It has 6 columns and 3 rows. But we might want to ask, maybe we didn't know what the dimensions of the matrix were because we didn't make it directly ourselves. And then we can use the function dim, and that will print again in the same order that it has 3 rows and 6 columns. So this is a kind of X and Y order of the information that you would see in graphs and so on. So we have 3 rows and 6 columns in our matrix. And then again, we can ask what type of data is contained in the matrix. And here we'll say double.
Before you continue, James, you guys can see James is working on the script. We've been working on the console. You can either do that on the console or on the script you can highlight, and is it highlight and then enter so that it runs?
Yes, sorry, I forgot about that. So yes, do you think I should work in the console instead to be clearer?
I don't know what they prefer, but yeah, we've been working just on the console.
Might actually do that for clarity then.
Okay.
Cool. We can follow up. Thanks for pointing that out. That's really useful. Okay. So we can also look at the class of the matrix example, and that will show us that it's a matrix, which is not surprising because we made the matrix, and then we can look at the structure of it as well. So what's inside it? So it's numeric, 1 to 3 rows, 1 to 6 columns, and it starts to show the values that are 0, 0, 0, 0. So one question here in challenge 6, which I don't know the answer to, I'm going to guess. It says, what do you think will be the answer to length matrix example? And I think it's going to give the number of all the values as if they were in one long string, so 18, but I guess it could also be the number of columns or rows. Okay, look. So there are challenges here. Have you been doing all the challenges on the screen, or have you left any for people to do later, Senate? Do you think I should do them?
Yesterday, the long ones I left so that they do it at home. Because we are doing them in the examples episode we're on, so yeah, you can choose which ones to skip.
Okay, cool. True. Just looking at the challenges. What I would think maybe we should do is take questions. So just to summarize the data structures part. So there are a few challenges, I think 7, 8, 9 at the end of the data structures page where people could follow up if they want more information. Just recovering what we have spoken about in this episode. It's kind of about reading data in and having data stored in a format that you can work with and that is required for you, whatever you want to do next. There are some important common data types, particularly for types of vectors, and that includes double, integer, which are numeric, logical, which is yes, no, or true, false, and character, which is like letters and number strings. And then data frames and matrices are structures with 2 dimensions, so they can have rows and columns and can have different characteristics too. So what questions do people have about data structures before we move on to exploring data? Okay. So the next one is exploring data frames. I think data frames are the structure that I work with the most. So I think that's why they have this whole, we have a section on them here. And then as we go, then we have data frames for maybe half an hour to an hour. And then we get into more complicated stuff, including making graphs, which is really a fun part. That's one of my favorite parts when you start to see pretty graphs. Okay. So this session, what time did you start today, Senate?
9:10, we just waited for those who were a bit late.
Okay, so there is a break scheduled quite soon, but I think I should make a start on this episode and try and get like maybe halfway into it, and then we'll have a pause. Does that work?
I believe so, yeah.
Because it would be quite nice to get some of this done.
Before the break.
Yeah, I think I should start anyway.
Yeah, start.
Okay, so yeah, we've seen a data frame, and this is one of the most common data structures, as I said. It's what I would have called a table before I started working in R. It has rows and columns where you store information, often about observations or samples in the row, and then variables in the columns. So that's any type of measure or data. And we're just going to go through a few ways of kind of manipulating data frames in this, including adding and removing stuff and combining them, and then displaying a few bits of information. Okay, so we're going to make a new data frame called age, and it's going to have 2, 3, 5. And if you remember, we have to have this thing C to combine the 2, 3, and 5 as, in this case, I guess, a vector. We also still have our cats. I can check what that is. Cats is a data frame, and it has the information we saw earlier. Well, you can see now that Yes, this will be so this is a numeric double. So then there are the values of age are 2, 3, and 5, which is the same number of rows we have in our data frame called cats. And so it's possible this could be very neatly just stitched onto the end of our table. So there's this function called cbind, which I think means column bind. And that means you can take a data frame like cats, and then the second argument in your cbind command will bind on as a column whatever you put in the second argument. So here, now you can see that in the column furthest to the right, the fourth column, we have age. So age was created as a separate object, and then we just bound it to the end. So what's important about this, of course, is that they have to have the same number of, they have to be the same length, they have to be the same number of rows, because if age has more values, in this case 4, now we've added a value 12 to the age variable, we're going to get an error message. Kind of makes sense. You can't just plonk on the end a vector or that has too many values. Of course, if we saw that error, we would know, okay, I need to double check how many rows are there in cats. How long is age? Those don't match. And that's how we know. So we can go back to the original age object that we had, 235. And again, we can use this cbind to combine cats with the age data. But at the moment, when we run that command, it's just printing the output to the console. It's not actually overwriting or saving a new cats object. So if we want to do that, we use the same notation as we have been doing, this arrow, and then we can cbind cat age. And so by combining that, we can now see that cats, the object, has been updated. Well, the thing is, we can do the same thing. So that's what we've done to add a new column. But here we could do the same thing with a new row. So if we want to make a new row and add it to the table, it needs 4 pieces of information. Well, we know it needs a coat color, a weight, whether it likes catnip or not, and the age. And because these are all different types of information, some are numeric and coat is a character string, this uses different data types, so it needs to be given as a list. So in this case, we're going to do a new example with tortoise shell color. So that will be the color. The weight is 3.3. Likes catnip is given as true. Well, in a way, likes catnip is true. False. And then the age is 9. So we have our new row here. This is the new cat that's arrived. And we should be able now to just R-bind that row. So that's row bind before we use cbind, which meant column bind. And now we're going to R-bind the new data onto our cats. So cats was the original object, the original data frame. And now we're adding the new row using this R-bind function. And then if that's worked, you can see that that's okay. We've added the new tortoiseshell cat, and it's also converted the value of true into a 1. That's clever, isn't it? Okay, so that's if we have new data and we want to combine it with an existing data frame. the next thing we might want to do is remove data from our data frame. So what we've seen already is that you can get certain parts of the data frame out by doing something like that. So here we've got cats. I mean, in the square brackets, we have the value 4 to say we want the 4th row, and then a comma, and then a blank space to say we want all columns. So remember, before the comma is the row, and after the comma is the column, and that's how we're using to tell which part of the data frame we want to access. And in this case, we've said we want the 4th row and all of the columns, but we can also use that to say, we can also say the opposite of that. We want to remove the 4th row and show all of the columns. So here we've added this minus sign in front of the 4, and we are now removing the 4th row from the data frame. And so we could do the same thing to remove a column, of course. So we could just a reminder, cats, and then square bracket says we're going to look at the rows and columns. The rows are before the comma, the columns are after the comma, and we could then use the value 4, and that would print the 4th column, which in this case is age, and the values are 2, 3, 5, 9. As we know, we can see that in the cat's data frame above. But we could then use the minus 4 to say we don't want the 4th column anymore. Now age has disappeared. So this is, just to show how you can remove data. So that works well if you always know the position of all of your columns and rows. But in some occasions, we might have lots of different data frames with similar data, but the order of the information might be different. So the age might not always be in the 4th column, and we might want to look up we might want to find the name, the column we want to drop, we might want to find by name and then drop it. And so we can do that using the names function. So the names function would tell you the names of the columns. And so we know here the names, just to remind us, we haven't overwritten the full data frame.
Please, James, could you go back to how you got to how you got to the new row?
Sure, yeah.
The addition you made to get to new row. Yeah, the command you gave, let me see.
Yeah, the new row part.
Yeah,
Let's do that again.
down a bit.
So what we're going to, I'll show you that again. So we're going to say, if we had the original data frame, cats, this is the one without the new row, right? So it just has the original 3. Then we're going to make this variable, this separate object called new row. And that was a list because it has different data types. We called it. And this is just the information we want to add. I said this. And so this is the information we want to add. In this case, we've just made the information here, but it might come from a different process. It might come from a different data set. Maybe you've downloaded 2 data sets and you want to combine them. And so we've got our new row. You can see that?
Yeah, why did when I wrote it, I had an error sign? Why?
What does the error say?
Okay, let me see. Maybe
There's a second part as well. So remember, we have to do them
maybe I
bind,
didn't.
cats, new
Okay,
row.
I've seen the problems. Okay.
So we combine the 2 by using this bind, which binds the row to the previous object. And then if we want to make a new object cats, so overwrite the object in our computer's memory, then we need to assign it as we've been doing with this arrow thing. Did you find the error?
I think so.
Okay, so we just do a few more. I know it's break time, so we'll do a few more and then we'll go to break. This is really important that you can, for any, oh yeah, that is right. At any time, oh no, actually not done this right. Sorry, I've not done that right. We need this. We also need to add age. So there you go. So we need to do both of those steps. First, we're going to add age by cbind, and then we're going to, and then I'm going to add the new row. So in the end, we have our full data frame, 4 columns, 4 rows, and we've started with 3 by 3, and then we added age, and then we added the new row. Okay, so at any time, we can look up the names of all the variables in our data frame. This is very, very helpful.
Don't
we
go,
often want to
don't get
know
away,
which
don't get away from that place. I want to take a picture.
of this. Yeah, okay.
Yeah.
I'll leave this.
Please.
And
Obi,
something cool we can.
Obi, you can use, it's on the manual.
It's not all of them.
It's not. It
We are
is.
working from here now. I'm sharing the link again. That's the link I'm working from at the moment. It's about halfway down.
Okay. Okay.
It's just before removing columns.
Okay.
And so because we have this named cat, well, we can search this. We can look with, or we can ask which of those names match a given string. So in this case, we can say which of those names match or are found in age. And this is going to tell us, yeah, which of our names of our data frame variables matches what we've supplied here. And you can see it's false, coat, weight, likes catnip, and then age is true, because of course we know that the age column is the 4th column. And we can then use this to tell us which columns we want to drop. So now imagine we want to drop the age column. We're now going to combine this information. So again, we know that this is going to give us the string of false and true. So which names of our data frame variables match age? Well, false, 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 true. And then we can use that information to remove columns from our data frame. So here what's happening is we have just a string of false, 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 true. And if we use that to select a column, we could use this same format with square brackets, and then this empty space here says we want all the rows, and then we could use drop here to get just the 4th column because it says false, 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 true. Or then we could put the minus sign in front of it, and then we'll get the first 3 columns. So this is maybe a little bit more complicated because we're combining 2 things here. We are saving the output of the first command, names in age, and then we're using that new variable called drop to perform something else, which is subset, basically remove data from our data frame. But what's crucial about this is you could have 10 different data frames, and they might have age in a different position, different column position, but because you've looked for the location of that flexibly by doing the names in age, now it would remove the right column. It would know which number column to remove if we want to do that. We will look more about this in operator in the next section, but this is just to show another way of removing a column. So I think we should take a break now. We're halfway through that and we can finish it when we come back. Do you think maybe to make up some time we could come back in 20 minutes instead of half an hour? How is everyone feeling? Or does everyone want a full half-hour break? 20 minutes, okay. Okay, well let's call this a break now and we'll come back in 20 minutes. Sorry again for being so late. And if anybody, if there are questions here, please let me know. Otherwise I'll see you in 20 minutes. We'll come back at 11 o'clock local time.
Yeah, Jesus. Yo. Hello. Is James there?
Yes, I'm here.
Yo, James, I committed a blunder. All that I've been working, I cleared it off, and I needed it. I wanted. Oh, well, it is okay. I ran into a problem of
Mhm.
this where we are now to recombine and do some stuff, and all the things I've been doing, I've cleared it off. I'm not happy.
Okay, I will paste you the key commands and you can, because I think we only need this one. I'm just going to
Exploring data. Let me check.
I'm going to copy and paste it in the chat the key commands that you need to. We basically only need to make these data frames again, right? Because the rest of the stuff, if you want to like look through the material again, you can always look online.
You're going to paste, is it what is in the data frame there or what you have typed?
I'm gonna, yeah, just give me a second. I'm gonna put it in the chat so you can catch up quickly.
Okay.
This kind of gives a summary of, I think,
And
I
my
think
cat
this will,
has been corrupted,
your
I
real,
recombined and recombined and
your cat
recombined.
in real life. I hope not your real cat, your our cat.
The cat I have here has been recombined and recombined, and I have is it 12 objects and 3 variables? I had 4
Interesting.
variables with 8 there. I got that part, but
Mhm.
subsequently, I don't know what happened that the age issue, I missed it. I don't know. That's where I was struggling to get back to and I cleared
Okay.
all that I did. But
So
my cat,
I just put in the chat how you can make cats, and then how you can make the extra column, and then how you make the extra new row. And so if you copy and paste all of those lines, all of those commands, then you should be back to where we all are.
Hello, James.
Hello.
Will that also help me with the original data for cats? Will that also help with that?
That will reproduce the cat's data frame. Yeah.
Okay. Yeah, okay. I'm
Is
lost
that what you
there.
need?
So if yes, I mean for the original data,
The original cat's data or a different data set that we used yesterday?
the one that you are working on right now, the one that you started with.
Yeah, we're going to continue working with cats for now. So you can, if you also copy and paste those lines,
Mm,
that will be
okay,
good.
thank you. Thank you very much.
thank you, James. I think it's helping me. I just pray that I get it through. Yeah, why doesn't it come on when I click enter? Why don't I see the things? The output.
If you want to show that, so what we've done so far is just combine with saved objects. So all of those commands are creating a new object. If you want to show the object for a data frame, you can just write the word cat and then it will show you.
Okay. Okay. But subsequently, if we begin to work, will I get the output?
Could you write cat in your RStudio console and then paste the output in the chat so we can check?
Let's see what I did, and I put. Okay, it has come on now. I typed cat. The output came on. It's okay.
Yes, not.
Don't come here because we are starting now. Okay, things. I was trying to say before.
Sinner. Yannick Sinner. Chinese. Okay. So I think we should get going again. What it would be useful to know is, in general, how are people feeling about what we've covered so far? I guess let's just say with all the R stuff we've been doing in general. Could you react or comment? I guess a thumb up or a cross or some kind of creative way of showing how you're feeling about the R stuff already and whether that will inform whether I go a bit faster or a bit slower, I guess. Trevor, how about others? How does everybody else find the R so far? And do you think we should go faster or slower or the same? Okay. Oh, this actually has a slow down, speed up thing. Thank you, Dorcas. You've just, I didn't know that exists. You're just showing that for the first time. So I will keep an eye out for that. If there are parts where you feel like we're really going too slowly, you're always welcome to put speed up, and vice versa. If we're going too fast or you need something repeating, but you don't want to say it, you can always send that reaction and we'll keep an eye out. What I think is important to remember is soon enough, we'll get to making plots and all of this will become very pretty and rewarding. Okay, so we're going to do, I mean, it's just more and more I understand that kind of, at least in kind of computational biology work and bioinformatics, there's not as much time making graphs as I would like. And there's always a lot of time making sure we process the data properly and efficiently. And so this lesson probably does, it shows the right proportion of time, making sure we learn about data structures and data wrangling. And then in the end, we will get to the exciting part of making the plots, but it's absolutely critical we do all this stuff. Do you agree, Senate, with that? It would be nice to spend more time in life doing plots, but we have to spend a lot of time doing data wrangling.
I don't know, whichever you think is better. Main thing, if they understand, that's all that matters.
Yeah. So if there's, yeah, I hope everybody understands. And as always, you can just. Okay, cool. Well, you let us know if there's anything specific. We're happy to repeat anything, individual commands, individual functions, or to repeat sections as well. So really don't feel shy to let us know. We're going to do some more data frame exploration type things now, and hopefully that will help with this kind of data, help reinforce some of the data stuff. So where we are at the moment, we have, in fact, let's get rid of that. We have our cat data frame. It has 4 columns with different types of data in, and we have 4 rows. What would be nice here is actually a cat name thing, and then they'd be real named cats, and it might bring them to life. At the moment, we have a 4x4 data frame. Remember, we can check all of that stuff. Because a data frame is a list of vectors. So it's kind of a list, and it's a data frame. So we saw that we can rbind, use the function rbind, which means row bind, to add more data, add new rows to our data frame. But of course, we don't have to do that one row at a time. We could, in fact, combine 2 data frames together. And so in this case, it's kind of funny thing to do, but we could combine both data frames. We could combine cats twice. So we could actually append or row bind the cat's data to itself. And here you'll see the whole thing is duplicated. Okay, and now there's a challenge here that I'm not gonna do for time. But now we have realistic examples. So we're gonna start using real data, and all of this hopefully will make sense still when we're using real data. So the first thing we're going to do now, I'm going to make a fresh screen because we're starting with a different data set. So everybody should make sure you can do this part correctly because this is critical for everything we're going to do afterwards. So we want an object called gapminder. Oh no, I forgot it. That would have been funny. And to get that, we're going to read the data that is stored in the CSV we downloaded. So we're going to access that using the function called read CSV. And the only argument we're going to give to the function is the location of the data. And so if everybody is working following the structure we set up yesterday, then you should have a data folder, which you can see in the bottom right here of my screen. And within the data folder, the data directory, there is a gapminder underscore data.csv file. This is a big data frame with some information about countries. Look at that. Too much to even show. So I'll just show that again so it stays there. And this is a big thing. So could people confirm that that has loaded in properly for them? And if not, please could someone write in the chat?
I think mine went into the environment side. I didn't the data didn't pop up on the console.
That's okay. So does it say here in the top right, Gapminder?
Yeah.
Cool. So that means it's worked. So this environment panel here tracks all of the objects that we've made. So that's a good time to highlight this again. And so yeah, it's just useful to be able to have an overview of everything we've done so far. So we've got the age object we made, and then if it says Gapminder here,
Please,
that
I
means that
couldn't
it's created.
read data / gapmind and score. Okay, let me see. Why is my own not coming in?
So if you want to if you want to download the file to where we are now, you can probably do this, download file. I'm going to copy and paste this link in, and I'll copy it in the chat, and you can copy what I'm doing here. And it's also just at the top of realistic example on the Carpentry's page we're working through. What I'm going to do is download file. So this is going to download the file directly, and the dest file argument will tell you where you're going to save it. And we're going to type data gapminder underscore. Oh.
Can I ask,
Mhm.
is able to access website and download into it?
Yeah. So that
Wow.
I've just shared the whole command
Sorry,
that I've run. Mm-hmm.
my this thing is not reading it. I don't know why.
And then the other thing you can do is if there's a
So
problem with, yeah,
I'll send it to the chat. You'll see what
could you
is.
send, the best thing is to send the error message to the chat, and then we can try and figure out why.
It's not giving me error message per se, but
What I'm going to show you here is I'm going to delete this thing, and I hope that it's going to re-download again. So you can also use this as a bit of a file manager. So my Gapminder is gone. I'm going to download that file again, and there you go. Luckily for me, it's still here. And then I'm going to use the up arrow to cycle through the previous commands, as we saw we can do in the shell. And now I'm going to do the same command, gapminder, read CSV. Obi, that looks like yours has worked. So if you could do,
it didn't
you
work.
could check. It looks like it's worked because it hasn't printed an error. So that means you could look in the top right in the global environment, and you will have something called Gapminder, and if that's there, then it will confirm that. The other thing we can always do is this function called exists.
Yeah, I have gapminder there.
That means it was worked. Well done.
Then why can't
Well done.
I?
That
Then
doesn't work.
what can I see it listed?
So you could just type Gapminder here, and that's going to show the whole data frame, which is a bit overwhelming. Or you could, what you're more likely to do is type this command called head Gapminder, and that will show
Okay.
you the top
Yeah,
number
it
of
has
rows.
shown.
Good. Nancy,
Nancy,
did
did
that
you
also?
manage? Oh, sorry.
Mhm. We asked the
Nancy,
same
did you
question.
manage? Yeah.
Yo, so
Yeah,
much,
sorry, I'm trying to get the
1,500
data.
rows.
Sorry, please could you repeat, Nancy?
Yeah, I'm trying to get the data. Yeah, so that's what I'm saving it as CSV first, and then I'll be able to enter the code afterward.
Mm-hmm.
Yeah,
Did
so
it
that's
work?
what I'm doing right now.
Is it
I was
working?
able to go to the site where the data is, so right now I'm following along.
Okay, cool. Remember, you can
Okay.
just, this command download file will download directly to your.
Okay, I did that, but
presentation.
it gave me an error.
Does it say that the date, the directory or the file location doesn't exist or something?
No.
What was could you paste the error in the chat and we'll try and fix?
Okay.
It's just that if it would be useful to have this data set saved and then then you'll be able to follow along.
Oh, yeah, yes, it's that the file directory does not exist.
Okay, because it might be that you don't have a folder called data. Is that possible? So
Oh,
if
yeah,
you're
yeah,
looking,
yeah, that's true.
and then, so I think you can do that by create. I've already got that. So if you, I'll type that in. If you run that command in your console, then it should create the folder called data.
Right.
Because what we're trying to do with this command here is the destination of the file assumes that we've already got a folder, a directory called data, and that we're going to save the file inside that. But if this doesn't exist, it might give an error.
Okay.
It's often that this kind of folder structure, making files, making sure everything, all the file paths are correct. So it's just always an important thing and a very common source of error, which is why it's important that we spend some time here, but also why we looked at it with Bash on the first day, the make directory and change directory, and yeah, all of that stuff's really important. Yeah. So Nancy, do you think it's worked now with the previous command as well, that download the data?
Can I ask a question?
Mm-hmm.
Does the file CSV file needs,
Mm-hmm.
does it need to be converted to another type of file extension before we can use it, or we just leave it like that?
No, I prefer CSV to Excel. CSV is a lighter format than Excel, and so it's sometimes easier to have things as CSV if you're going to read and write them often. For example, to R or something.
So as I've been able to get the CSV files, I should leave it like that.
Yep.
Okay.
If it's loaded, then you've done something pretty good, and we should be happy, I think.
Yeah, it loaded, though it just stopped halfway by 166, but there are 1,500 and something rows. But it stopped at one.
Because that's just all that. It's not saying that the rows don't exist. It's saying that it's not showing them all on your
Yes.
screen, because otherwise
Yes.
you don't need to see 1,700 rows. But it shows that it has loaded correctly, so we're happy.
Yes.
Nancy, could you let us know if that's worked for you as well? And if anyone else has any problems loading this data, please let us know and we'll try and troubleshoot.
James, would you please go up a little bit up so that you can see how to load the data?
Yes, of course, I will. Sorry, I should have left that. It's this command here that I've just pulled back up with my.
Okay.
I guess what's important is that the file path we use with this command is the same as the one in the where we downloaded it to. And of course, you could change that if you downloaded it somewhere else.
Yeah, I got it. Thank you.
Great. Okay. If anyone else has any problems with the data, let us know in the chat. Otherwise, I would assume we've all got that loaded and we can start looking at this real data set. So we had a data frame before, which was just a few rows and a few columns about cats. It wasn't a very big data frame. And now we've got Gapminder. I don't know why it's called Gapminder. It has 1,704 observations. So already instead of 3 or 4 rows, we've got 1,700 rows. And there are 6 variables, which I suppose is not too much. We can use this function called str, structure, I think is short for, and it will tell us some important information about our data frame. So it will tell us the name of each of remember the variables can have names. And so in the first column of the output, it tells us the names. So we've got country, year, pop, so this is population, continent, life expectancy, and GDP per capita. And then it will tell us the type of data contained in each of those variables. So this one's a character, integer, numeric, a character again, numeric. And so this is like a really interesting or really useful way. If you've got the new data set and you're not quite sure what's there, this is a useful way of getting a first overview of what's contained within it, which is a really important first step. So this is a kind of high level summary of the types of data included, but you can also do a summary of the data themselves. And this is using a function called summary. And then we're just using Gapminder as the only argument. And then for each variable, it will summarize the data for you. So you'll notice here that country and continent, all it says is the length. We know there's 1,704 in both, and that they're characters, because I guess it's kind of hard to summarize the data contained in a character string. But for these numeric type variables, it will also give you some information about the data themselves, and that includes the minimum, mean, median, and maximum. So again, this is useful to see as you get to know your data, some key statistics, some key summary statistics, which I think is really, really useful. So we can confirm that for the individual variables themselves. So for example, it says above in the top, in the first structure, that year is an integer, and then those are the values here. And we can see from the summary that year has numeric looking data, but we could look at that. We could look at that specifically by doing type of, which we've seen before, Gapminder $year. And this is a reminder that we can use this $sign to access variables or columns within a data frame. And so this is going to confirm that, yes, our year variable is an integer. We can also use the structure function on an individual variable. So again, this time we're going to do Gapminder $, say country, and it will tell us the same information as we saw here. The name is country, it's a character, the type of data is character, and these are some of the values. So here we've got character, the length, and then the sum of the variables there. We can also ask questions about the data frame as a whole. So for example, we might want to know the length of Gapminder. And so here, I guess the length could be the number of rows or the number of columns. In this case, it's 6 because a data frame is a list of vectors, a list of variables. So there are 6 variables in our data frame. So the length of the data frame is stored, is given as 6. And that's why if we type of Gapminder, it's going to tell us that we have a list, i.e. a list of variables. We can also ask directly about the number of rows by typing n row. That's going to tell us that there are 1,704 rows. And there's a similar function n col, and that is the number of columns. It's going to tell us that. So here in this screen, we quite neatly see that there are lots of ways that we can get key pieces of information out about our big data set. And I guess the critical thing is here, if you've got a data set with thousands or millions of rows, it won't be possible for you to kind of summarize by scrolling through the data, all of the information there. Whereas with the cats one, we were just printing the whole cats data frame and saying, oh, look, there's 3 rows, 4 rows, 3 columns, 4 columns. When we have so many data points, it's not possible anymore. So we use these functions to summarize that quickly for us. Another useful thing is that, like we have names, we also have col names, and as you might guess, that tells us the name of the column. Actually, don't know the difference between col names and names. Maybe names is more flexible and col names is only for a data frame. Anyway, those are 2 ways that you can access the names of the columns. And remember, we can do things like select individual variables by their name, or we could subset to remove certain columns by using their name as well. And then finally, we could often, all of that information is really helpful, but nothing is quite the same as just making sure everything looks okay visually. And we can use this head command that we've seen before, and that will print by default the first 6. There you go, width order is 5 or 10. The first 6 rows of the data frame, it will just show you all of the information there, all of the data and all of the values.
Sorry, can I ask?
Of course.
Do you see there by names it produced 1 and 2 and 1 and 6?
Mm-hmm.
Was there? I thought I expected it to be 2, 1 and 2 instead of 6. Why is it that so?
This is a good question, and even I was asking this myself the other day when I had some complicated data output. In this case, it's just counting the number of what object elements in what's being printed. So literally, it's 1, 2, 3, 4, 5, 6. I thought the other day it was telling me something about rows and columns, and they didn't make sense. But actually, when you just have lots of, so say you had 25 or 30 elements in the vector you were printing, it might be useful to know roughly where each value was, right? So like 1, 2, 3, 4, 5, 6. Yeah, it's just counting them. In case you want to say, oh, the value number 18 looks weird, or no, you would say the other way around. There's a value that looks weird or has got an NA or something like that. Somewhere's missing. Which row is that in? Then it's easier to count and identify which row that's in if there's some count values here.
Okay, thank you.
So we've seen that head produces the top 6 rows of our data frame. Can anyone remember what, I think we looked at this with bash. It's the same word here. Can anyone remember what we would use to look at the bottom 6 rows of a data frame?
Could you come again?
So we've used the command head to look at the top 6 rows of the data frame. Can you think of what command we might use to look at the bottom 6 rows of the data frame?
We use tail.
Yes, exactly. The same as in Bash. So again, we might want to make sure that the bottom of the data frame is there. There's no random empty rows in our file or anything. And so tail, just like in Bash, will print the bottom rows of our data frame. So challenge 4 here, no, challenge 3, sorry, is to save this as a script, which scripts have been kind of, I'm not really sure if they're formally introduced in the lessons. I couldn't see that when I was checking earlier. But challenge 4, Sonata, we haven't really seen scripts, have we? Or we haven't, there's no part that really
No,
emphasizes
there's
and
no way
introduces
it
them.
introduces. There's no way it introduces scripts. It just mentioned that that's where you write your scripts.
Yeah. Do you think it's worth like so challenge? I thought, well, what I maybe expected was somewhere there would be like a section called scripts, and this is how you use them, and this is what they're for. But because that's not there, they kind of get mentioned without really ever being explained. Do you think it would be worth pausing here to show how a script works? Because challenge 3 is to do that, and I also think it would be useful for people to be able to repeat previous commands. What do you think?
Yes, because it's the same code, just different, just that everything is in one script.
Yeah. Okay. Well, maybe I'll spend a few minutes explaining because I do think it would be useful. Okay. So on challenge 3 of this, we're working on data structures part 2, which is exploring data frames, I think. In fact, we're just at the end of this now. We're at the bottom where it says challenge 3. And it asks us to go to File, New File, R script. And so up until now, we've been running all of our commands in the console, which is the panel on the bottom. So for example, we run this. And so one of the problems with this is that if you want to look for something you've done previously, you have to scroll all the way up with manually like that, or you can look through with the arrows. But actually, this is not that easy to navigate. And Obi, as you said earlier, you made the data frame and then you had a problem with it, or you can close your session, and then you basically have to do the whole thing again, right? Run all of the code again. So R has this kind of, well, not R, but there's a system in coding called that means we can put our code in a file and run the code directly from a file. So it's really easy to track what we've done. And if we want to run it again, it's very easy to do that. And then we'll still run the code at one line at a time, and the output would still show up in the console, but just having a separate script at the top will separate the code from the output, and it's easier to follow. So I'll show you what I mean by that. The challenge says, I'll paste it in here. Oh, that doesn't make sense. It says, write an R script to load in the so I'm actually gonna manually save that. I've just done Control and S to save that. I'm gonna make, I don't know if you can see this thing coming up too. I'm gonna make a new folder called scripts. It's gonna be load gap minder. Okay. So I've now made in my my working directory, in my project folder, something called scripts. And within scripts, I have this, within the scripts folder, I have this file called load gapminder.r, which is of course this. And so write an R script to load in the Gapminder dataset. Well, we know how to do that. We are going to read CSV, and then we give the path in quotation marks to the file, and it's called gapminder_data.csv. So you can now run this. So this is just the same as, I'm going to copy and paste this straight down here. So that's exactly the same function. You could type it in the console directly, and it will create this object called Gapminder. But also I could run it from here. And so there's a button at the top called Run. And so if you click Run, it will run any line of code that your cursor is on. So my cursor is on line 4, the Gapminder one, and I'm going to click Run. But if you keep your eye on what happens here, when I click Run, that command shows up because it's actually running the code, and the console is showing the output of the command. So just to be clear about what that means, we can then use the head command that we've been using in the console. And when we click Run up here, it's going to show the output of the command. Well, actually the command too. First the command itself, and then the output in the console. So the reason that is very useful is because we might want to come back to this later on, and for maybe we closed the R session and we're going to have lunch, and we come back and we realize, oh no, I need to know how I loaded the data. Well, all of this is safely stored.
Hello, so do we need to write this thing at the same and save it the way you did it?
Yes, I would suggest everybody do this
But we can't see
because,
what you wrote. The letters are too small.
oh, sorry. Is that okay?
Better, but when you do it like that, everything might not be seen. Sure. What's that thing now? Yes.
Hello?
I don't know. How do I write something at that place? Because it has the things that were there.
So is this panel showing for you at the top? Oh no, actually what you can do is to make that happen is click on File in the top,
Yes.
New File,
Yeah.
R script.
R script. Okay.
And
Okay.
that's going
Then
to open a new script up there. And so
yes.
then everything you write in the R script, you can run or you can execute using this button. And then that will, in the same way that it runs in the console, it will run. But what it gives you is the output in the console, but a clean record of the code that you've run or that you've written in the script as well. So we can easily track what we did without having to go through all of the output every time we want to go back a few steps.
Write an R script. Write an R script.
I got some different results. It says function and some information. Should I paste it on the chat?
Yes, please.
Cool.
So you're missing in read CSV, you're missing the brackets telling R where to look for the file. So that, oh wait, hold on, it should really be, that's what's missing. And so the whole command should be this.
Sure.
Oh, look. Oh, I didn't know you could do that. Look at that. Uh-oh. How do you don't do that? Oh, no. That was silly.
You save it as
I'm just going to stop. How does anyone know how I can remove this annotation that I've just done? That was silly.
oh.
It just popped up and I wanted to see what it did. Right, I'm going to stop sharing and then reshare it. Hopefully we'll be gone. Cool. Sorry about that.
Okay. Do we save it as what?
So you can save it here as you can see this, right? Gapminder equals.
How do we save it? Go to
That's the
file,
same
save
as
as.
before.
File, save as.
No, this isn't. No, so you already have the file saved, but can you see my screen? My R window.
Yes.
So to load it into R, you need to have this command read CSV, gapminder equals read CSV, and then
Okay. So we don't save, we are not going to save the command we wrote.
sorry, yeah, you might want to save the script itself. You can do file save as.
Hello, it gave me an error.
Can you post it in the chat and I'll have a look?
Okay.
So we pause it. So you've got here. The full command you need is just this, because at the moment you've said read, you've written read CSV twice in there. For those who have done this already, you might start playing around within the script of what else you could do now you've loaded your data. For example, you might be able to do this, and so any of the previous commands we've run, basically you can run directly from here. Or you might change the structure to the summary, and you can click on this run. Will always run your command, but the shortcut that I always use is Control and F. So here we have, just to show that again, I'm going to clear that. I would do Control and F, Control and F, Control and F, and that's going to run all of the commands. And now you see you have all the output here, which is useful with what we want to view, but actually we might also just want to see the code we've written and run, and that's also useful for that. So that's the end of this section anyway. We can just troubleshoot any more issues here. We're going to go to the net. Oh, no. Oh, yeah. Okay. Cool.
Where
We've
do
got a
we
little bit
see
more
the
time.
result? Where do we see the results?
Of what?
The run we do on this thing we are doing now.
Yeah. So what I've got so far in here is this is the output. Read CSV doesn't have any output. It just saves the file, the object up here in the environment. And then head will print. If I run the command head from within the script, it will show the output in the console. And then if I run the summary from within the script, remember here I'm clicking on run or pressing Control and Enter, and it will show it down there.
I've not seen my script in this. I didn't see it. I did file save as. Then I put script. Then and it gave me script.r and I saved.
Mm-hmm.
So why am I not seeing it?
So do you not see it in this panel in the top left?
It's on the top left. I wrote it, but
Yeah,
I'm
do you
not
need
seeing it on the
yeah.
top right.
So if you type, can you run this command from your script, gapminder, and then click run to load the data?
On my screen, where I used to be running it before.
So what
The
you do
down
is
one.
do you have the script file open in the top left panel?
Yes, it's open on the top left panel.
And if you click run, if you go to this line and maybe select it like that and you click run, what happens then?
Which line? Come again.
This one, gapminder, the one to load the data.
Uh-huh.
If
Okay,
you
I click on that plate, then I run.
Yep.
Okay. Okay, cool.
And what happens? It works?
Let me do it. It gave me the same thing down.
Yep. And no error message?
No, you just wrote the same thing, gapminder equal to read something.
Oh, I think that's worked. Okay. So could you please put something into chat to show that you're okay with the making this simple script and saving it and then running a command using the run button up here? Thank you, Nancy. Thank you, Trevor. Great. Okay, thank you, Potemelo. That was a bit of a detour, but using scripts is a way, it keeps a much better record of what you've done. And I think it's really, well, I do everything with scripts more or less. So I think it's really useful to see. We actually come directly to the end of this exploring data frames section. And I hope that we're going to use this again in the next episode so we can continue to build our script. Otherwise, maybe we'll make a new one. I don't know. So what we've covered is, I mean, we've done quite a lot of kind of filtering and data showing and data moving and cutting today. But in this episode, we've seen binding by columns with cbind, binding by rows with rbind. And then we've looked at various functions for accessing kind of metadata or structural data about our data frame, including the summary function, which summarizes particularly numeric values in giving you information about the data themselves, but we also can look at structural data with the number of columns, number of rows, the names of the columns through col names, and also head and tail we've seen for showing the top few rows or the bottom few rows. And that's always a good check to make sure that there's no formatting problem as you've been reading in data. Of course, reading in data through the CSV is absolutely critical. We've seen how we can download data to a file using R. I think that's pretty cool. And then finally, we've saved this in a script, which is a really clear record way of what we've written and a really neat way of running things one row at a time or one section at a time. So we've got a little bit more time now before lunch. The next section is subsetting data. I'm just going to check what the... Cool. And then we get to control flow. Okay. So I'm going to now work from now on in this script. And the nice thing about script is that you can add comments. That's another nice thing. So by putting a hashtag at the start of any line in your script file, this tells R that this is just a comment that we're writing to tell ourselves and each other what we're doing. This isn't code we want to run or execute in the console, right? I hope that makes sense. So we can do that and nothing shows up here because we're not actually running anything. We're just writing a comment for ourselves. So the final part of this kind of data wrangling section is to look at subsetting. And we're going to use this with, we're going to look at various ways of subsetting. So kind of filtering out not only data frames, but all kind of objects in R. So we're going to start by creating a variable or an object called X, and this is going to be a bunch of numbers. So I'm going to type out the command there, and I'm going to press Control and Enter, and on a Mac is Command and Enter. Now, that's going to save this object X. I'm going to add separately the names of X. Remember that we can add names to, this would be the equivalent of naming the columns in a data frame, and we're just going to call them A to E. So that's kind of cool. What we've done is first we created the object containing just the numbers, and now for each of them, they're effectively, we're treating them as if they were, columns, each with one row, one value, and now we've given all of them names. So then what you'll see is we have, it's not quite a data frame, but it kind of looks similar in that we have columns, A, B, C, D, E, and the data with those numeric values. I actually think it's not a data frame, it's going to be... Okay, so it's just a kind of numeric object, but we can still give names to it, which is kind of cool. Oh, look, it says here, these are called atomic vectors. This is just the simplest type of object that we can have. And so what we're going to look at now is just how we can access the different values in this, the different ways we can access the different parts of our vectors, of our objects. So first of all, we have X. X, if we type that, it's going to give us the whole, all of the information in the object, all of the data. We've seen before subsetting using square brackets. That's what we were doing before with our data frame to remove or filter just certain rows. Well, we can do the same here. The thing is, before we had, yeah.
Sorry, James, I don't get the result at the lower part of my work.
So have you been, do you mean, so if you type this in the script?
Yeah, it doesn't come like your own in the lower part at all.
And then if you click run, what happens if you click run?
Okay,
Can you see where my mouse is?
run. It didn't do. Okay, let me see. When I did run, everything, they came out and it came out.
Yeah, so
Quick means
it's
I
working.
need to click run for every data I put before it can show.
Exactly. So we're just typing it in here is just writing out the words. But you also would have to type enter. If you were in the console, you would have to type and you would have to press enter at the end
Yes,
to show
yes.
it as well. So it's just one thing is typing out the words, the code, and the other thing is telling the computer now, I want you to run or execute this code that I've written. So before we were subsetting or we were filtering or removing data using a square bracket and a comma to separate what we wanted to do with the X, which was the rows and the columns after the comma. But in this case, because there's only one dimension to our object, it's just those 5 values, we only have a single dimension and therefore we only need a single number here to subset. So for example, we can pick out the first value by running this command X and then in square brackets 1, and similarly we can pull out the third object like that. We don't have to stop at one value, one part of the object. We can get more than one by typing this. And again, you'll see in the console down here that we've now got C and D, which correspond to the third and fourth elements in our vector. If we had lots and lots of values that we wanted to pull out, we could use this notation here, which means 3 to 4, or let's show 3 to 5, and that will pull out C, D, and E. That's the third, fourth, and fifth elements in our vector. And this is just to say that, yeah, the colon in this case means go from 3 to 5. And of course, we could show that to use all of those. In fact, this is another good way of doing it. So what I'm going to do is we're going to show we can use it to pull out single so we use single elements, multiple elements. In this case, I don't even know if we need that. This is called slicing, I think, where you take out a row, what would you call it? Where you take out, multiple elements by just saying from here to here. It's called slicing. Okay, so what do you think will happen? Does anyone want to guess what will happen if we put x10? We want the 10th element of the vector that we made. At least because we only have 5 elements in our first vector, we are probably going to break it. We're asking for the 10th element, and of course it doesn't exist. Exactly, thank you, Nancy. Nancy is completely right. It's going to tell us this is NA. This
Why
doesn't
not
exist.
error?
Good question.
Mm.
Sometimes I actually have no idea. Why would you sometimes have an error and why would you sometimes produce NA? And this is like a really serious problem sometimes because you might run your code, like I was saying the other day, you might have 500 lines of code and you might try and do something like this and assume that you've pulled out a subset or you've replaced some values in a data frame. and it might not produce an error, and you might not notice it says NA, and you've accidentally introduced NAs to your data frame without knowing. Whereas that's why an error is useful, because it's a big red error message, and you go, oh no, what have I done? And you go and correct it. Whereas in some occasions, you might not want the whole pipeline, the whole script to break. You might just want it to say, this is NA, there's no value to return here, but continue with the rest of your code. And how you decide whether you want an error or whether you want to kind of silently show this NA, it's kind of a difficult decision, and I guess will depend on the context. But apparently here, this is worth an NA. It's not going to break your whole code, but it's not going to return anything. So this is something that, remember, all of these things in green after the hashtag are just comments, and that's to remind ourselves and myself what we've done and why we did it. Apparently, I've never done this before. You could type x0 and it's going to tell you this. An empty vector. I've never used that, and I don't know why you would need to use it. Okay, so as we saw before, we could also remember we've got in our vector, we've got A, B, C, D, E, and each of those has a value. And we can pull out single values by typing just, for example, x2 will give us the second item, the second element, which is B. We could also do the kind of inverse of that by putting a minus sign in front of the 2. And this will tell us now, this will print for us all of the values in X apart from the second one. So that is removing B. So we have A, C, D, E. Of course, we can do the same thing for multiple elements. We have to put this C to tell R that there's going to be multiple arguments that we want to use together. And this is going to now just show us B, C, D, because we've removed the first one, A, and the fifth one, E. We can also slide that.
How can I tell it to produce what is the value of B if I want to?
So if you wanted B, we could look that up in a number of ways. The first would just be to know that you want the second element, because we know B is going to be second. But we're going to come in a bit to how we can pull out specific ones, which you'll be able to do by name, which is kind of cool as well. So this is analogous to previously when we were looking at data frames that will find by the name of that part of your object. It will find that value. And of course, again, this is important because sometimes we won't know what columns, how the columns are ordered, but we will know the name of a column, and we won't want to every time have to look through our data and find, okay, column B is in the second position or the 8th position. We can just look them up directly by name. So if I was looking up column B, I would probably most directly do it this way. So remember what we've been doing so far is just showing on the console that we've removed certain elements from our object. So here is A, B, C, no D, the D is missing, and then E, but we've not actually changed X yet. So remember, now we can overwrite, we can save this new object X by using the arrow sign that we've seen. Oh, I wasn't expecting that, to be honest. Okay, so I was expecting it would still be A, B, C, E. Oh yeah, because I did it twice, sorry. Okay, so I've done a mistake here. And what's nice about the script is that it's very easy for me to go. I know that I've actually removed the 4th value twice because I ran that twice because I did the one with the equal signs by accident. And so I want to now recreate the X object. So because I have this all in a script, I can go straight to the line that produced X. So I'm going to write X. I'm going to do Control and Enter to run that line. I'm doing Control and Enter again here to set the names again. And I'm just going to type X in the console, and hopefully it will come back with all of the values. So I hope this starts to show how it's useful to have a script, because you make a mistake like I just did. You can go straight to the line, the previous line that you use to create the data that you're interested in, the objects you're interested in, and run them again. And we're exactly back to where we want to be. I don't need to do these bits, which we've just looked at already, but they don't actually change our data at all. But what I do want to do now is come back to here and remove. So remember, if we just ran this command, it would remove the fourth element, which is D. But if we run it with this arrow, it's going to overwrite X. And now we're going to have a new object X, which will be missing D. Okay, so we're scheduled for lunch soon. Well, now in fact, I think. This is the right day, yeah. So we're scheduled for lunch. There was a question. The next section is subsetting by name, and then okay, we'll just do subsetting by name because we had that question, and then we'll have lunch. So you can subset also by name, which was a question that we just had. And we have our X object, and then we can just do square brackets with the name of the element we want to show, and we can print that. And of course, again, we can combine multiple ones with this C brackets, and then it will show all of the elements, all of the parts of our vector that match, whose names match these values. So we're going to get A and B. Okay. Now is lunchtime, so let's pause for lunch. It's 12. We'll come back at 1, and then we'll move on through a couple more sections in our. What questions do people have about subsetting and data wrangling before we go to lunch? Okay, so if we have no questions, we can have lunch. We'll come back in an hour. That will be 1 o'clock local time, and we'll continue with this. If you have any questions over lunch, I'll be mostly at my desk, but pottering around a little bit as well, making some food. So you can either shout out or write a question in the chat, and I'll get back to you when I'm here. Otherwise, I'll see you in an hour. Well, at 1 o'clock, 55 minutes, 1 local time.
Okay, thank you.
left, right, and center. Time. Especially if you don't help anybody, nobody will help you. Are you hearing what I'm saying? So let us pray for all the kingdom. Fire, Father, I give you praise. In Jesus' name I pray. Marriage challenges and issues. Their kingdom. Fire, Father, because he knows by prayer you are catching. But we pastors don't keep time. By the special grace of God, I'm a person, I'm a person, I like keeping time. But once I keep the time 1, 2, 3 in the same place and people don't turn up, I cut off from that place. Don't see me if you want to come, I come at your own time also. Pastor, I'm begging of us, if we see the thing, let us be a team. I was here 9:15. The door was locked, Sister. My phone, nobody was here. It was me and her. We arranged this. If I was a new person that want to come and join the pastor, do you think after that I will come back? I won't. Let us respect time. It matters a lot. If you say 10, we are going to stay from 10 to 1 o'clock, like that. May God help us in Jesus' name. We don't need to pray. There are some things you don't pray about. Exactly. It doesn't need prayer. No. If pray, once you think about it, that's not prayer. Don't need prayer. Okay. Lift up your hand and say, Father, help me to discipline myself. Jesus' name. Clap your hands as I write down the prayer. God bless you. This is the mic stand. Okay. Good morning. Morning, sir. I'm sorry if I kept late. Actually, I called until you called me. No, he was telling me. I was calling her, but she couldn't tell her about it. I was about to go out and receive a call from a lawyer. You know what that means, to get a call from a lawyer. So I asked him to get some documents or to bring money. So I have to run around. So preach to them. The result is attracted to come and know how did it happen. We need to pray. It will affect your anointing and your ministration. Everything about your life will be wrong. But if the marriage is going on, when there is no money and other things, the encouragement will be there. Because once your wife is glad, supporting of what you are doing, it will go well. It will go well. So this is God. Great peace and orderliness in the marriage of pastors. With and without the pastor self. In the name of Jesus, we will begin to pray. Father Lord, we appreciate for them to be standing in our strong church this morning. Our president is away in Pretoria with some of our members as well. So they are doing the election today. So the president is there. Your presence is against the onslaught of the evil ones. Father, we call so you and we appreciate you because you have answered. In the name of God, the Father, God, the Son, God, the Blessed Holy Spirit, in Jesus' name. Amen. Thank you so much. We really need to pray concerning that in a different way. We need to pray for most of our members, not just most of our members, most of the pastors. I'm included. Some of us, our papers have expired a long time ago and we find it difficult to do it. Immigration problem. You see, before you go out tonight in South Africa, you must wash them. Church need money. Verse 5. I am the vine, you are the branches. If you remain in me and I in you, you will bear much fruit. Apart from me, you can do nothing. Apart just pray. Father, I just want to thank you for your word this morning, the entrance of your word. Revive us and strengthen us as we life in this world and to remain steadfast, strong, sound, deeply rooted in the mystery of godliness as we wait for the blessed hope, the glorious appearance of our Lord and Savior Jesus Christ, the marveled among us who have believed his glorious appearance, to the praise of his glorious grace, in the name of Jesus Christ. Amen. You see, one of the problems we are having in the body of Christ, even amongst us, the men of God, is to believe and accept the fact that we are short-sighted and limited in knowledge. In every area of life, we are limited. You see, Bible speaks so much on the subject of the flesh and the spirit. Bible speaks so much on these two subjects, the flesh and the spirit. Paul, in his letter to the church in Rome, Romans chapter 8, around 13 there, obviously, he says, if you live according to the flesh, you will die. If by the spirit you put to death the desires of the flesh, you will live. I strongly believe that the greatest problem we are facing as believers and the pastors, that the devil access into our lives is a life according to the flesh. That's all. Flesh is an invitation to satanic dominance over your life. And that is where we are missing, where we are. We think that every decision we make is God decisions. But we forget that most of the decisions we make are fleshly driven. And it even affects our preaching, our administration, because most often our teaching and preaching is fleshly again motivated. Where we allow rules and regulations to be the dominating factor in our teachings and preachings. But thanks be to God that is, bringing some kind of awakening to many pastors now are now getting that insight into the subject of the flesh and the spirit. The flesh is very powerful. Remember our brothers in Genesis chapter 11 who were building the Tower of Babel. Then you find some expert architects, building planners, according to the kind of knowledge and technology they have as of that time. They were able to come together as one people, having one way, speaking one language. But the spirit is not there. But it is fleshly decision, empowered by fleshly capacity and ability. Together they were able to build that gigantic structure that nearly get to heaven. Imagine if God did not look down and see what these guys were doing. By the power of the flesh, they could have been thrown in. Imagine they never succeeded. People God said, if I allow these guys to continue, trusting me, they are never they will bring it down. It's okay. I get you in flesh. I'm stronger than you. Okay, let me disconnect you from understanding each other. And you know it's not. Project. No matter.
Those things that peanuts are still the way. And that God will make us, it's a way for us to travel.
Hello, everybody. Welcome back. I hope you had a nice lunch. People will hopefully start trickling back in. If you have any questions or comments, please let us know. Otherwise, we'll get going again in a few minutes. Okay, could I have a tick or a hand or something to show that you're ready to start if you're back and you're ready? Thank you, Trevor. Oh, Abby, do you have a hand up? Is that it means you're ready to go? Thank you. Okay. So I just remind everybody that we are working on, hey, where have you? Thank you. So just to remind everyone, at the moment we're doing this subsetting episode. So we've seen already quite a few different ways of subsetting, and there's a fair amount left of material in this episode, but I'm not going to go through all of that because we are a little bit behind the schedule. I think we've seen some subsetting already, and basically it's going to show you again these different methods of subsetting for different types of data structures, which we've kind of looked at a bit already. So there's subsetting lists, vectors, data frames, matrices. But I think it's fair to summarize that all of the subsetting will fall under more or less three categories. One will be by position. So if we have just to remind ourselves, we have in this case, a vector, which is called X. We can subset that by position. So we can get the first position, second, so on. Remember, I'm just typing this code in the script at the top, and then I'm using run to run each line that I've selected with my cursor. And we can subset by name, which refers to the name of the element, which would be the name of the variable or the name of the variable in a data frame. So here we could do that. Or there's one that we haven't spoken about so much, which we should have spent more time on, but I think so we could just give a vector of logical values, false, false, true, and in this case it will say what, basically saying no, no, yes. So in this case we'll get C, but we could change that. Yeah, where we need it for. And this we could do by a condition as well, I guess. So it could be, so if we have values here, it could be so there are different ways different approaches we can use to filter our objects. Now this is shown on a simple, getting notifications from Teams, but Teams is closed. Oh, God. Sorry, hold on. Sorry about this. Okay. So the other thing to say is that this is showing how we would subset a vector with one dimension. So it's just A, B, C, D, E. But of course we have our cats. And if you have two dimensions, you need to subset in two dimensions, either by position, going to get the first row, the fourth column, or just show the first row, so on. And when it's a data frame, of course, we can subset by name, find the column by name as well. Anyway, this is just to summarize what we've looked at today. There is a lot more kind of practice and information in the page that I shared, but I will suggest that if you want to understand more about that, that you have a look separately. I mean, all of this material is really, really good and easy to follow without someone talking through it. I think talking through it, of course, will help, but now we've spoken about it a bit. I think you'll all be able to read through this and yeah, follow along and learn some more details from the information here. In the end, we go to list subsetting, which will have some similar principles, or there's an additional way to do that. And then data frames, which we've kind of looked at. So I would recommend having a look at this separately, but I'm not going to go through in any more detail now to catch up some time. All right. How long we anticipate this? So the next thing we're going to look at is it's called control flow. I don't find that super helpful. No, can you see? I'm making a new script file here. You're welcome to continue in the same script, or you can make a new one for this episode as well, this chapter of the teaching. Oh gosh, I'm not even sharing. Oh no, I am. What can you see what can you see? My R. Yeah. So there are quite a lot of cases where we'll have a script building up. We'll read in some data and then we'll do some processing actions. And then if a certain condition is met, we will want to do something. So I guess another way of saying is we might not want to apply all of our code to every part of every data set. There might be situations where we only want to perform something under certain conditions. And so this is what we're calling control flow. It's not really, I don't really see why, I don't really understand. I don't think control flow is the most intuitive way of describing that, but I'll give you an example and hopefully this will make sense. So say we have a value, x is 8. Well, we might want to know if x goes above a certain threshold. In this case, we can say 10. So the logic here we're typing is if, I mean, this is telling R that we're about to give it a threshold, a condition to test. And the condition we're asking is our x value greater than or equal to 10? So if it's telling R be prepared to test out some logical condition, and the logical condition is x is greater than or equal to 10. And so whatever comes between the next squiggly brackets will be executed, will be code that is run if the condition is met. So, for example, we might say if x is greater than or equal to 10, we might print a message saying the thing is we've just set our x value to 8, so this condition is not met. We know that x is only 8, so we don't get any message from here. However, we could say that x is 10. I've just changed the code at the top. And now we will get a message that says x is greater than or equal to 10. And the reason that runs is because, I guess, the logical condition that we're testing will return the value true. So this condition has been met, it's true, and therefore R will perform whatever actions are contained in the squiggly braces. But there's also a second way we can, there's a second layer we can add to this. So at the moment so now we've set x to 8 again, and if x is greater than or equal to 10, of course this is now false because x is 8. But we might have a second condition that we want to test at the same time. So we can use this word called else. And then we have the squiggly brackets again. So if this condition is true, if this condition is met, we will perform this action, print this message, and else means any other situation. So whenever this condition is not met and the value returned is false, we would do whatever is in this set of curly brackets. Okay, so now we're going to run that again. And we have x is 8. So we know that we're first going to test, is x greater than or equal to 10? The answer will be no. So this will be false. We will not print this message. Therefore, the flow of the information, which is how we start to get towards this name, the flow will be to look at the else. There's an else statement. So that means we will print this statement here. So if I run that by clicking on run or pressing Control and Enter, you'll get the output that x is less than 10. Again, we could change this to 10, and now I'm just running that again by Control and Enter, resetting the value of x, and this time, because x is 10, we'll get the other message. The first condition will be met, the value will be true, and therefore we will print x is greater than or equal to 10. So I use this kind of logic very, very often in my work. It's extremely powerful, and it makes your code more efficient, and it it helps avoiding all sorts of errors. You might say, for example, you might have lots of different data sets, and some of them contain a value, a variable, and some of them don't. And you might want to produce the mean of a value, the mean size of a turtle per population. But if that variable is not present, then of course you won't be able to take the mean. So your logic could be looking at our turtle data frame, and if there is a variable called weight, then calculate the mean weight, else print a message saying no weight variable found. So then you're prepared for both scenarios where your target variable is present and when it's absent, and you'll either get the statistic, the output you're after, or you'll get a message explaining why. And so this, it comes up all the time. It's very, very useful and very powerful, and a little bit confusing. So we're going to go through a few examples of that now. I'll do a couple more and then I'll stop for questions, because I think this is a little bit tricky and we won't go too far ahead, and try and make sure nobody's left behind. So we've had so far if else, but we can also have if, else, if. Maybe this is going to make sense already, or maybe this will be confusing. And so we're going to do the same type of logic again, we're going to test whether x is above the threshold. Well, again, we're going to do the same logic. So we use if to say we're about to provide a condition for R to test. And again, it's going to be is x greater than or equal to 10. And if that condition is met, we're going to print the same message, x is greater than. And so what we had earlier was else, print Okay, so that would be in any other situation, print X is small in this case or something else. But we might not only want to know whether X is above 10, we might also want to know whether X is between, within a certain range. So we might want to know if it's above 10, then print a certain message, but else, if it's not above 10, also check if it is greater than 5. So now we're using the if statement again, the if function, and we're going to provide another condition to test. And this time we're testing whether X is greater than 5. And if X is greater than 5, we're going to print another message, which this time will be then we can still have our final message that says, if this is not met, if this condition is not met, and this condition is not met, so we get to this point in the information, in the kind of logical testing, we're going to know by this point X is less than both 10 and 5. So in our case here, we have set the value of X to 8. So the order of the testing, the order of the checking is going to go, if X is greater than or equal to 10, we're going to print this message. Well, we know X is not greater than or equal to 10. So we're going to go to the next test by this else says now check something else or now do something else. And the thing we're going to do is another check with if. So we're going to check another condition. And this time, the condition we're checking is whether X is greater than 5. Well, we know this is true. X is 8. So we expect that we will see this message. X is greater than 5, but less than 10. Okay. And again, we could set X to any value. If we set X to 10, I know I'm just rerunning exactly the same code with a different value. It's going to tell us the first message because that's true. And if X we set to 3, X, we're going to follow that logic to get X is less than 5. All right, I think we're going to take our first pause there. What questions do people have about what we've looked at so far? Either about how we use if and else, or just in general about the flow of checking here.
Yes, could you go up a bit where you started the if command? You've done so much and we are lost. Okay.
Yes, that's why we take it. I think it's a lot already, isn't it?
Yeah, I just got the first part of it. Okay, the thing starts with the hash, the command out if -- else. Then
Because we have a hashtag here, this is just a comment. So this
yeah,
is
I
just
know.
for us to organize.
Yeah.
So this is the first
Yeah.
part of the,
So we established there that X is less than or equal to 8.
Mm-hmm.
Then is the first argument is if X is greater than or equal to 10, print X is greater than or equal to 10. Or else print X is less than. This argument, most of the time I get confused.
At which part with the else?
Like that we know X is less than or equal to 8.
Mm-hmm.
Then the argument is if X is equal to or greater than S, print S is greater, which is not. Then else print x is less than 10. But what was the printout we had?
So for this one, if we just run these lines, it will tell us x is less than 10.
Okay. The next command is we assume x there is less than 3. Is 3 equal less than or equal to 10 if
So
x is less than 10.
let's space these out. I'm just adding extra lines. So it's a bit cluttered. So just to really emphasize here that there's 3 kind of tests, well, 3 conditional things going on here. First is, so we set our value for x. First, we check whether x is greater than or equal to 10. Because the answer is no, it's only 3. Then it goes to the next statement, which is else. And then it's saying, well, if x is not greater than or equal to 10, then do this. And that's when we have our next test, which is if x is greater than 5. And if that is true, then we're going to do whatever is in these curly brackets. So here we would print this message. And if that is also not true, then we're going to kind of cascade down into this part else. We're going to get bumped down in order of the lines. So if this is not met and this is not met, keep going. What do we find here? Well, else just means in all other cases, do what's here.
Okay, could you go back a bit? I just want to take the snapshot of that area. I will do it myself. Oh,
So remember,
I can't get
that's a bit
all
too
of them.
small.
Let's, yeah.
Yeah, all of this, I'm just working directly from the
Let
link
me
that-
take it from there. Then we'll scroll
Yeah.
down again. So as to get the whole thing.
This is towards the top end of the page in the link that I shared. So yeah, again, all of the information will be available afterwards. And if you want
share
to
the
take
link?
a snapshot.
Which
Yeah, I just
page
put it in the chat.
Okay, scroll down. I didn't see the page because I looked for it.
So I just put the link in the chat of this Teams meet or Zoom meeting.
Okay. Is it the
Hello,
okay, let me see.
Obi.
Yeah.
I don't know if I could this could help or if I understood you. On X, you said X is less than or equals to 8. It's X equals to 8, not less or equals to. Also goes to 3.
That's a really good point, actually. Thank you. Thank you. So this sign, yes, it's true. We're not saying not to confuse. Okay, there's 2 things that can be confused here. We're not saying x is less than or equal to 8, but rather we're using this very R-specific thing, which means that we're just assigning this value to this object. Thank you. That's a really, really good intervention. So this
So
is
what
not
does
saying.
what does that value mean?
So this is what we've been using all the time to assign. So this is we're giving an object a name here, and we're assigning a value to it. And that sounds a bit complicated, but that's the same as when we were saying that cats is equal to a data frame where coat equals, I can't remember what they were, and so on. Do you remember? So that's to show that this value here, this symbol here, is R's way of assigning a value to an object. Because remember, what we're doing very often is creating these objects that stay in our environment, and they're things we've kind of saved as objects that we can interact with and use and compare and analyze. And so this is the little symbol we've been using all along to assign value.
A value to an object. Okay.
But
No
suddenly, this is a little bit confusing, you're right, because it looks like less than or equal to. But yeah, that's a great point that no, we're not saying
Thank
X
you
is
for letting
less.
us know.
Yeah. And so here, true, and just I hope it's big enough to see this is the equal sign. This, and then here we're using the assignment operation, and here's the equal sign, and that is a great intervention because yeah, those are doing different things. Okay, yeah. You can combine that in one line. Sometimes I guess this is worth saying. Oops. So we have our if else statement. So so far we've had if else, if else, if, and now we're going to have if else. And this is going to perform basically the same, exactly the same as this, but within a single line. And as Sanate was saying yesterday, we don't need to learn all of these things off by heart, but it's just in case you see this later, not to be confused by it. So we can, instead of having the code set out over several lines, there is a single function called if else. Oh, look at that. That will do this in one line. So the if else function takes 3 arguments. You can see in this yellow pop-up box. The first is the test, then what to do if the test is met, and then what to do if the test is not met. And so, for example, we could say the test is x is equal to or greater than or equal to 10. And then I'm just gonna, so what to do if that is met? Well, we can print x is greater than 10. And now that's the second argument to this function. And then just to say after the third argument to the function is what we will do if the condition is not met. Okay. So it's going to run off the edge of the page there. So now we can see that in a single command that would be on a single line if I had more space, we're doing the same thing. So I'm going to run first this whole block of code here, this if, and then else as separate commands, and this one is going to do exactly the same thing. But look at that. I don't know why it's printing it twice. Because you don't even need that maybe. So in this case, we don't even need the print maybe, and yeah. So this is just combining all of this into a single neat line, and it's kind of to be neat and to save space, which is an important thing sometimes when we have long and potentially messy code. So we're using in a single function, if this condition is met, the condition is x is greater than or equal to 10. We're going to just say x is 8. If this condition is met, we do this, which will print the first message, x is greater, and if not, we'll print the second. Cool. And that's just to show that you can do that on a single line. Yeah, so I think actually, Trevor, we'll just quickly stop on your question, which is, what about when you have, say, a vector? How do you if else that? And you can do here. So remember, we're setting up a vector now, and maybe one of them is less than 10 and one of them is 10. So what would you do? Well, actually, I'm just going to copy and paste that. I'm going to just see what happens when I don't know what will happen if you post the whole thing. Okay, so you get both. I guess it's doing one, it's testing the condition for each of the elements of X. That's actually really clever. So then you're going to get a test for each, first for 3, X is less than 10, and then 10, which is really cool. But what I end up doing quite a lot is you can use these things called any, and any will test all of X at the same time. And it doesn't quite make sense in terms of the messages now, because it should say any of X is greater than 10. I follow actually. I guess it would be no effect. Okay, so what I've done here is changed it so that we have multiple values in our vector, and we're saying if any of the values are greater than 10, and we're going to print the message any of X is greater than 10, which isn't great language, but it does the point. And if none of the values are greater than 10, we'll get none of X are greater than 10. All right, maybe it's that. I don't know. And so that's just to show, because we've got a 10 in there, we know that we'll get the first message. So now we're providing a vector, which is just the values C and 3 and 8. And now we're expecting none of X is greater than 10. And then there's also a similar one that tests all values. So we can do the same here. We can say if all values of X are greater than or equal to 10, this is a really useful one as well, where you just, maybe you don't, if you've got 2,000 rows, you don't want to know whether every single value is greater than a threshold or is present or absent. You just want to know if any of them are meet your condition or all of them are. And so in this case, we know that all values are not greater than 10, but we might have here 10 and 15. So I'm just going back up. I'm resetting the value of X to 10 and 16. And so we now know that sum of X, this in any condition, we know that at least sum of X is greater than 10. It doesn't make, that's horrible language, sorry, but then we'll go to the all test and we'll say, are all values of X greater than or equal to 10? And now we know that they are, the 10 and 16. So we'll get this first argument, which is this first action, all values greater than 10. So yeah, we're just summarizing again, we can do kind of simple if else type things on a single value, and then we can make ever increasing complicated kind of chains of commands where we can get really specific actions. And it kind of seems complicated, but it's surprising how often you really want to know, you know, in this condition, do this, and in this set of conditions, when these parameters are like this, do this. It's actually really powerful and flexible to be able to chain together these if checks in certain ways. And then we can do it in a single line with if else. And then just to add, you don't have to do that for a single value. It can be a vector containing multiple values. Okay. What questions are there at this point about if, else, and kind of conditional actions? Or could you give me an indicator in the chat or in a reaction whether you'd like to go through this again or whether you would like to move to the next section?
Is it the modification of the one we just did?
Yeah, so would you like to look at the if-else stuff again or go through any specific questions about that, or would you like to go to the next section?
Can I
Take your time.
ask,
Of
if
course.
on the if else, both
Mhm.
are for any value and all values, why is there any after bracket and all after open bracket? Do you see any and all? Yes.
Yes.
What's that
So
for?
the important thing here is we're so I'm just going to separate these onto different lines. So we can do help. If else. So the first thing, so you can see here that we're using this function called if else, and the first argument we provide is the test. Oh, that's such a terrible description. Basically, it's a conditional statement, and the answer of that is going to turn into true or false. So at the moment, we know that X is 10 and 16 because we've supplied two values. In fact, it could be longer, right? It could be 5. So X now is a set of values 10, 16, 17, and 5. And if you wanted to ask whether X is greater than or equal to 10, you would get for each element in our vector, for each of those numbers, you would test the logic. So here you have true, 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 false. So you're asking one number at a time. Is 10 greater than or equal to 10? True. 16 is greater than 10, so that's true. 17 is true. And 5 is not. So you get false. And I guess there will be a case where you'll have a variable in a data frame and you'll want to know have any values exceeded a threshold. So you might say, okay, I have the sea temperature in Cape Verde for the last 10 years. I want to know if any of the times it's exceeded a threshold for coral bleaching. You've got hourly temperatures for the last 10 years. This, I don't know how many hours there are in the last 10 years, but I imagine it's many thousands. And so you might not want to know whether each of those individual values has exceeded your coral bleaching threshold. This is just an example. But instead, you want to know if any of the values, any of the temperatures have exceeded your coral bleaching threshold. And if so, then you might, I don't know, you raise the alarm. So in this case, remember that if you just executed the code inside the thing, you would get, inside the brackets, you would get a comparison of each value to your threshold, which here is 10, but you can then add this any, and any will collapse that and compare all of the values against 10, and then tell you if any of them are true or false. So here, it's going to collapse to true. So I guess it's saying, is this true in any of the comparisons? Given a set of logical vectors, is at least one of the values true? Okay, that's actually really clear. So if when we do the direct comparison, we get a set of logical vectors, true, 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 false. And then we use any to say, are any of those above our threshold? Which in my example would be, are any of the temperatures of the last 10 years above the coral bleaching threshold? And do we need to quickly raise the alarm? And similarly, we have this function called all. So given the logical vector, are all of the values true? And that's also handy because sometimes we want to make sure that, for example, if we've loaded a data set, we might want to use only baby turtles. We want to exclude all of the adult turtles. And so we will say, we might have a logical check that are all of the ages within our data set below the age of 5, whatever you call a baby turtle. And so this is just a check to make sure every value in your vector is meeting a condition. So again, if we just compare one at a time, remember that X is 10, 16, 17, 5. So if we ask, is X greater than or equal to 10, we'll get true, 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 false. But are all of the values greater than 10? No, this isn't true because we have 5 in there, so it's false. And in the example of checking the ages of the turtles in your data set, you would know, uh-oh, our filtering hasn't worked. I need to go back up and figure out why there's a value lower than the threshold than I was expecting.
That's good. Thank you very
So you
much.
can do,
Second question: are they functions?
are they functions?
The any and all, the two
Yeah, they're
ways.
kind of,
Are they functions?
they're functions of their own.
Okay. No, I understand. Thank you very much.
That's okay. You can get complicated. Okay. Dorcas, does that go towards helping with you as well, or is there anything specific we could talk about with conditional statements? If you have anything else, please write a note in the chat and we can come back to it. Otherwise, I will continue a bit. So the thing we've looked at so far is kind of conditional, performing actions conditionally. If a certain condition is met, then we will do action X, which so far we've only seen printing messages, but of course that could become more kind of impactful data analysis type actions. But there's another type of control flow that we're going to look at now. And that is called for when you want to repeat an action many times. So you might have a set of values that you might have a set of values or objects, and you might want to perform the same operation on those. On each of the elements in your list. And if you wanted to do that manually, you would have to say you wanted to print the numbers 1 to 10. This is a very creative example and exciting one. You would have to do. Okay, so now I'm going to Control R and go all the way through this, and we're going to print our numbers out. But you can imagine if you want to repeat these operations over and over again, and the operation is complicated, and you have dozens or hundreds or thousands of things to repeat the action, this is quickly going to become very messy and quite awkward to work with. So instead, R has something called a for loop. And again, this is not immediately clear what this will mean, but once you see it, hopefully, once you see it in action, hopefully it will make more sense. And the logic of this is for iterator, and that's not clear what that means until you see it, but hopefully it will. In a set of values, do something. In fact, do the same thing to a thing. So what this is going to be is we're going to have a set of values, which in our example here will be 1 to 4. And we're going to have some kind of flexible variable, which is going to loop through the set of values, one value at a time. And for each of those values, we're going to do the same thing. Okay, that's a bit abstract and maybe doesn't make sense yet. But in our example before, we're going to say for number in 1 to 4. Oops. Okay. Hooray. So what we can see here is the manual way that I did at the start. You have to type out print, 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 print. But in this case, you can just have one command where we have our set of numbers 1 to 4. And for each number, and this is the complicated part, I guess, is or the part that's really important to get. This number is a kind of flexible variable, which is iterating through one at a time. So first it's going to say when number is 1, print number. and it will print 1. When number is 2, print number, and it will print 2. When number is 3, print 3. When number is 4, print 4. And this is the basics of a for loop. And that, of course, can be super flexible. 1, it could be 100. I don't know, you can use any kind of, become super flexible here. Okay, so this is the basic of a for loop and how we use that to repeat the same action multiple times without having the horrible process of having to type it out individually. If you're really if you really want to quickly go complicated, there's something else we can do, which is we can have a for loop within a for loop. And so now, I'm going to do this separately first, actually. So we're going to say, so here we've done a loop that says for letter in A and B, print letter. So we're going to print first A and B, and then we can have our for loop that does the same for numbers. So for number in 1 to 5, we can print that.
You're a bit fast. We can't catch up with you. Before we write something, go to write, come back. The whole thing has gone off straight.
True. Sorry,
Because
okay.
we can't copy.
Yes,
So we
yes, fair
find
enough.
it difficult.
Yeah. I think that's a good point. Okay, let's go through this one slowly again then. I'll give you a bit of
Let's
time
go
to.
up. The up ones, we couldn't even get one. I was trying to do for the iterators that you went to numbers. Before I could write numbers, you went to another thing, and I don't know where
Sorry.
again.
That's fair enough. Yeah, I'll go slowly through this one. So the first thing we've got is just to print these numbers 4 times. That one's easy enough to type. I'll leave that one. And then you're right that I went too fast through this. So we're going to first print. We're going to show that this can work in a number of contexts. So the first thing we're going to do is we're going to have C, A, and B. So we're going to go through effectively a list of letters.
For letters and is it?
Yeah, for letter in C, and that is just to combine what's in the brackets. And so if you type 4 and then in the brackets, letter in CAB, and be careful that you have all of your brackets in order here. You need one set of brackets around the values you want to loop through because we've got this C function here. Then there's always a set of round brackets around the iterating information for the for loop.
Why is this other bracket for on top of a special bracket where you say print? Then why is it print encircled in it?
Good question. So this is because the I guess the syntax, the way we write code when we use a for loop is separated into 2 parts. The first part, I mean, we could have it like this, right? And so there's 2 parts to this that you can see. Oopsie daisy. So you're gonna, like as above, we're gonna have 4, and that tells R that what's gonna come next is gonna be the the iteration information. So this is the name of the iterating value. This is the flexible part of the loop, which is going to change through each time we go through the loop. And then this is going to be the list of things to iterate through. And so this kind of structure is always the same. And whenever we write for, we know that we're going to have some brackets, and that's going to, within those brackets is going to be contained the information like this in this exact structure. So I will know we're going to take this value and put it through what we have in here. And then the second part of this structure is what to do for each iteration. And so we have the curly brackets to show the action, the operations, and the code we want to run. And we have the round brackets to give information about how the iteration is set up. And so you're just separating the iteration part from the operation part. Does that make sense?
Okay, I now understand.
And it could all be on one line, and then it would be really clear we have the iteration and operation. But for some, I think to make it easier to read, we often by convention have this iteration stuff set up here, which is generally quite short, and then you'll have the operation within the curly brackets. So is this working for you, Obi? If you do that and you print, will it print A and B for you? Obi, is that working for you?
Let me do the first one, the letters, and then I come to the numbers. It just say print letters. Okay, print letters, that's why. Then yeah. I think I had a problem somewhere.
So the next thing for if anyone's finished the first part, the letters and the numbers, the next thing we're going to try and do is to combine them both in a double loop. So if you want to try printing the double loop of letters and numbers, please have a go and let me know if you manage to do that.
My own is not printing the numbers. Why? And the letters.
Can you show me can you show me the code and the output in the chat?
Okay, I wrote the two codes. I will send it to you.
That's working for me. I copy and pasted your code and that, so you can see that, can you? So I'm copying and pasting your code straight into my R console and I'm running that and it's printing.
Your own gave you a result. My own just said plus.
Okay. Is it saying plus on the side?
Yeah, yes, but where it's going to give me a console, the first argument I put is for the letters in C, that print letters. So it didn't print, and I put another argument again. It didn't, I don't know.
Yeah. So what happens is, this is a really good question, and in fact, I'm going to show you this, I think. What happens sometimes is you can give, it looks like this, I guess. And you're going to have just plus. And this means that you haven't closed the bracket somewhere.
Okay.
And I was getting upset. Yeah. And this is a really important one. I also remember getting stuck on this for quite a long time at the start and finding it very frustrating. But actually, all it says is one, you haven't closed the bracket somewhere, so you need to be careful with that. And you can escape that, I think, by pressing escape. Yep. So if you ever
how do I
notice
escape it? I escape.
you press, yeah, escape key. So
Okay.
this is a really good point for everyone. If you ever get stuck with these plus signs on the left and you don't know why, it probably means you haven't closed the bracket somewhere and you're putting loads and loads of commands on top of each other without finishing them. And so the best thing to do is just escape, go back to the start of your command, and then select carefully the whole thing and then run it. For example, now
But
we're
what I
running.
sent to you, it ran in your place.
Yeah. So if
The
you
numbers.
highlight all of it carefully and then click run, then that will work.
Okay, let me try it. The numbers first. Yeah, it ran. Oh,
Great.
thank you.
So has anybody managed to do the combined number and letter exercise? Or even more, would anyone be brave enough to share the code for completing the... Oh, maybe you saw it on the other page. But if anyone has freestyled the code for combining letter and numbers, it would be great to see it. Otherwise, I'll quickly show how we can combine these. So it's quite
You want
common
us to
for...
combine the two, the letters
Yeah.
and the numbers.
And then, so what happens quite often is there will be two parameters that you want to vary through. So it might be like, I have data on turtles. I have annual data. So I have data for every year in the last 10 years. And I have 4 islands. And so for each island, for each year, I want to go and calculate some value. So it might be that instead of having letter and number, we might have for year in, we'll just do a simple one here, 2001, 2002. Okay, so I've done that quite quickly, but it's just exactly the same structure as we had before. But we might want to know, what did I say before for island? But we might want to also iterate through another variable called island. So maybe we want to know for island in, these are the names of island in Cape Verde where we worked. So maybe, oops. So what I'm doing is printing first the year, and then we're going to print the island. And so you could, oh, look how naughty that is. So I haven't put my curly braces there. We need curly brackets for each of the commands. What's nice about this to help you with, because it's a common problem and it gets really complicated remembering where all your brackets need to go. So just to be clear here, we've got the first iteration. So it prints the year, and this curly bracket is closed here. So if you click next to it, they're both highlight, and that tells you, okay, we're closing this one here and that's there. And so within each year, within each iteration of our year variable, we're going to have for island in, and then here's the islands we work on. We're going to print the island, and here's the curly bracket that reflects the island loop. So if I run that, we're going to say 2001 Sao Boa Vista, 2002 Sao Boa Vista. Or we can just do we can just, oh, which one? Paste. We could even paste them together. So you could say, so we're iterating through two different lists or vectors at the same time here. First, we're iterating through year and then island. And once we get to this point here, we have a year, which comes from the first loop, an island that comes from the second loop, and we're printing a combination of the two. I don't think we should spend too much time kind of looking at or troubleshooting that. It's going to be, I don't know, I think that's quite complicated logic to quickly grasp, but it's again to show that you can build up these commands in a really powerful, flexible, and maybe complicated way. And again, it's just to show that this is possible. And if you ever see a double for loop, that you won't think that you'll be able to kind of approach it by breaking, understanding that there's two loops going on. First, you do the outermost loop, and then you iterate within the inner loops. Yeah. So there's one more thing I wanted to look at here. And then we're going to move on to plots, I think. It's my favorite part. We're going to just quickly look at because what we've done so far is just print to the console the output from the loops. We haven't actually stored that anywhere. And the thing is, everything that is created within the loop, every little object we create within the loop is only there because it's only kind of temporarily created while the loop is running. That's what's neat about them. You don't have to have everything saved forever in your environment. It iterates through them. But once the loop is finished, the information, the objects you've made within your loop are not accessible outside of the loop. But we might want to combine these, whatever we're doing within our loop, and then have access to it afterwards. And to do that, you have to do something a bit, it took me ages to figure this out. And I'm really happy that this is said early on in training now. Honestly, it took me months to get the hang of this logic. So before we run our loop, we're going to make a blank, in this case, vector, a blank list or a blank vector to store the outputs. So this is really important. It's just an empty vector. In fact, it says null. It's like it doesn't exist. It doesn't, well, of course it exists, but it doesn't have anything in it. So now we have an empty vector. That is going to be where we store our output. So just to give a simple example using numbers and letters again, we're going to loop through the numbers 1 to 5. And then we have curly brackets. So this is exactly the same logic as we've seen before. Then we're going to go through some letters. And in this case, we're doing the letters A, B, C, D. And at the end, oh, look, it's telling me already that I'm doing something wrong. This red line is telling me there's an error. That's good. Reminding me I need more curly brackets. Okay. And now we're ready for our loop. We're looping through first the numbers, then the letters. So I guess the first thing we could do is show you what would happen if we do that. So this is what will happen if you just loop through the numbers and letter, and then paste is combining the I and the J value. So I is iterating through the numbers, J is iterating through the letters. So there, this is a little bit complicated again, but just to remember that we're following the same logic of looping through. And in each kind of iteration of the loop, we're going to have a number and a letter. and we can combine those and print them using this double function called paste and print. So if you just print them both, it's expecting a single. Yeah, it needs to be pasted for the two can't be both. Print can't print both I and J at the same time. We need to combine them into a single pasted output. I don't know. That's just explaining why we have this print and paste. It's a kind of weird thing when you're working in a loop. You need to have print and paste. So at the moment, we have again printed this. I'm going to remove that. I'm going to put that in a comment so you can still see how I did it, but it's not going to keep happening every time we run the loop. But now we want to add our output to the output vector we created at the start. So for each iteration of the loop, we're going to make something called a temp output, where we are going to store the output of this iteration. So for the first round, it's going to say 1A, then it will say 1B, 1C, 1D. That's what's created through the iteration. And we're going to store them in a temp output variable or object, which will be overwritten during each loop. So at the moment, yeah, we're making this object, we're assigning. And then to just be clear what that's doing, we can print the temp output and it's going to print this, okay? So we've got a double loop, and for each iteration of the loop, we're pasting both the letter and the number together into something we're calling temp output, and we can print the temp output just to show that it's working, and sure enough, we have 1A, 1B, 1C, 1D for each iteration. And here we get to the final thing, which is how to add the temp output to the vector we've made for storing output. So now we have the output vector, which is where we're storing it. We're assigning using our assign operator that we've seen plenty of times. And now we're using this C again, combine values into a vector or list. And what we want to combine is the output vector that we've already made and the temp output. So the reason that this is going to work is because you'll start with an empty vector. Then for each iteration of the loop, we'll make a new object called temp output, combining a different combination of letters and numbers. And then we will combine the previous empty vector with the temp output. And every time we update the output vector, we'll be adding this new combination of the letters and numbers. So first it will just be empty. Then after one iteration, it will say 1A. Then after a second iteration, it will say 1B, 1A, 1B. Then the third, it will say 1A, 1B, 1C, so on until you have all of the outputs stored. Right, I'm going to give some time to think about this in a minute, so that's why I'm not pausing right now. And there you go. In the end, you'll have that. So we start with an empty vector, we iterate through the variables, make this new object, and then add them one at a time to the output vector. And again, this isn't critical to perfectly understand now, but what I would hope it stays in everyone's mind is when you're working with loops, the output you create need to be kind of carefully added to an existing object, to something you've made before the loop. And that's how you'll be able to view the object afterwards. So I think we'll stop there for this session. It's now 2:15. I think we should have a break now to allow that to settle. I think this this is the most complicated logic I guess we've seen so far. And I think it's worth having a pause to let that sink in a bit, and to of course ask any questions, and then we will come back. We will come back to do plotting. Yes. Cool. So let's have a 10-minute break, and we'll come back at 2:25 local time. I would, well, I mean, yeah, go and have a break and walk around and get something to eat or drink as you want. But also, if you want to ask any questions and go through this again, I'm kind of adding this break to have some time to reflect on this as well, because it's, yeah, as I said, the logic I think is getting more complicated, but it's super powerful, flexible, and useful. So I'll be here throughout the break, and Senate, I think, will be too. So yeah, if have a break if you want to have a break, and let us know if you have any questions if you want to ask. If not, we'll see you in.
Hello? Hello?
Okay. Could you let me know if you're back and ready to get going by a thumbs up or a message or something? Okay, cool. Just wait another minute. So we just went really too quickly through the if and else, and the kind of control flow logic kind of things. Well, quicker than I would like in an ideal world, but we have a lot of stuff to get through this week, and that's great because on the other hand, it means whilst we go through some stuff quite quickly, it means you guys are going to get an introduction to all sorts of kind of complex and useful functionality that comes with first bash and git and now R. And I feel like I would have liked more time to go through if and for loop just because of the logic, and it would have been great for you guys to have a bit more time to play with all of that. But it just is that we have quite a lot more material still to cover, and I think in these sessions, in the end, I slightly fall on the side of introducing things, introducing concepts, so you have some kind of introduction to them, because then at least you can recognize them later on. And of course, all of the exercises that we've been through in this workshop are available on the Carpentry's website. And I'm going to share the link for the current lesson, which is ggplot. That's for the current episode. But just to say, yeah, so even though it would have been nicer to have more time for you guys to play and do the challenges and so on, you can still do that at a time that's suitable for you. And I still think it's useful to be introduced to the ideas kind of conceptually, and yeah, hopefully it demystifies a little bit if and when you come into contact with these ideas later on. And now at last we come to my favorite part, making pretty graphs. So we're using for this section something called ggplot2, and this is a library. And we had a conversation the other day about what a library is and how sometimes we want to install or download or use code that somebody else has written and stored in what we call in a library, which is available on the internet. We download that, we load it, and then we don't have to make all of our own code from scratch, but rather someone else has already made these clever, very nice looking plot functions, and we're going to use those to make some nice plots today. So when I first saw ggplot, it took me a while, it took me a long while to understand what was happening, because the way it's written, the syntax is different it's kind of different to how we have seen code written so far. And so I guess this lesson is kind of to show how we build up plots using the kind of logic of ggplot. And that is, you kind of build up your plots in layers. So first, for example, you'll tell ggplot that what kind of data you want to use, and that generally means telling it which data set you want to plot, and then which variables you want to be the X on the X-axis and which variable you want to be on the Y-axis. And then after you kind of add that as a layer, and then after that you'll build in additional layers that define the details of the plot. So first you'll tell it which data set to use, then which variables to go on each axis, and then you'll go through and amend all sorts of tiny details about a plot that you never imagined you might ever care about. But it's super powerful, super flexible, and very detailed. So you might change the axis title, or you might change the color of the points, or you might change the axis limits. There's really loads and loads and loads of different things we can do. It's relatively easy to do those things once you get used to it. And in the end, the outputs really are good. Mm-hmm.
Do we get a new file for this? Like,
I think we're going to use Gapminder again.
no, what I mean is, like saving, we had that script. Do we still have to use it? Is it in the same script?
I'm going to make a new one called plots. But
Okay.
that's up to you, kind of. I like to keep different code in different script files. I think that's a nice way of organizing your project. That helps me understand the logic of where all my code is stored and what it's all doing. But that's kind of up to you. Sometimes it's nice to have one place.
Like now, if we want to use a name, we don't have names to use here according to this, or we just get our own name. How do we get it?
What do you mean by it?
You know, when we okay, I will say new project, ne? No, I don't know. Like if I have a script as file name. Now I want to save it in plot. Do I go to file save or what?
Yeah, so I'll just show you again how we do that. So when we open R, we might be in the console, and then we have our
Okay.
files here. This is just like opening File Explorer on Windows. Just, you can click through and see files. So to make a new script, you do File, New File, R script.
Mm-hmm.
And then you can do File, Save As. Then it's going to give you the pop-up. And I'm going into, so here's my kind of project, my main project folder. I'm going to go into scripts. I'm going to call it plots.r.
So we clear all these things now. I want to clear it. I don't know. Okay, clear.
So in my new script, I'm going to say, sometimes I just it's nice to have a comment at the top to introduce ourselves to what we're planning to do. So the first thing we're going to do is load this library called ggplot. And we saw that the other day. Does everyone have this installed? I can't remember if we installed it. If anyone doesn't have that installed, please could you let us know?
I don't have it.
Okay. I'll share with you in the chat the code for installing. Oh, I can show. So here we can have. So to install packages that we don't already have, there's just one line of code. Install.packages, and that's going to look up on our package website the name of the package which you specify here. And here it's called ggplot2.
ggplot2, okay.
Mm-hmm.
You use command line to do that?
No, you can do that in R.
Okay.
So if you type install.packages and then in the brackets has to have quotation marks ggplot2, you can just run that. Has that worked?
Give me an errors. Okay, I think I've seen the problem. Yeah, it's running.
And Boitomelo? Does that work for you as well?
Yes, I got it right. Thank you.
Right. So this is like one of the first external packages that we're using in the workshop. And this is a great example of a really common and powerful and popular one. And so we're gonna get started straight away. How do we specify the data for a plot? Well, ggplot has one main function. This is very nice and simple. Don't even know what they do. ggplot. And so in this function called ggplot, we're going to tell it what data we were. Oh, hold on. That means we need to do something else, doesn't it? Sorry. We're going to go back a step. We need to read in our data, don't we? Unless you already have that in your session. So we're going to say gapminder is read.csv. And then in the read.csv function, we're going to say one argument, which is data. So if anyone has restarted a session, then you can read in again. I guess most people will continue from the same session, but if you can't reload that data for any reason, please let us know. I'm going to assume people have loaded the data because we've been working on that already today. So the first thing we're going to do is specify the data we want to use. And that is simple enough. We have ggplot, and then we specify one argument. Data is equal to gapminder. And so before I run that, I just want to highlight that here, what we've done so far is used code like functions in this format where we have the function, then we have brackets, and inside we just put a single argument. And sometimes we've even put more than one argument, but we've never really talked about how that is processed. And by that, I mean, when you have a function like ggplot and the arguments are given, say, as in this order, how we've been working so far is just to provide one argument, gapminder, and that would correspond to the data argument. But sometimes we want to be very explicit about what we're doing, and so we say the data we're using is gapminder. And I'll just be really clear about that because it's going to come up a bit. So when we're using read.csv, as we've seen several times, we do read.csv, and we only really provide one argument, or we've only provided one argument so far, and that corresponds to the file argument of the read.csv function. So here, of course, the file is the name of the file which the data are to be read from. But actually what we're doing is a shortcut. What we really are saying here is the file we want to read is called data/gapminder. And so we're just doing the same thing here. We're specifying that when we want to make a ggplot, the data we want to use come from this object gapminder. And I'm just saying that because I don't want it to be confusing that we have this new structure, this new data equals structure. But also to say that whenever we're using a function, we're providing arguments to something within the function, an argument expected by the function. And we can be explicit about that in some cases, or in some cases we can take the shortcut and it will assume that the argument is the first argument. Okay, this is a bit of a sidetrack. So going back to what we're doing here, we're telling ggplot to make a plot, and the data we're using is that. And now everyone, if you run that, you should see a big gray square, and that's okay. Because all we've done so far is say what data we want to use. And as I said before, this is something you build up through layers. You specify the layers one at a time. So far, all we've done is the data, so it doesn't know what we want to plot. But if you get the gray square, it means at least your first argument has worked. So the next thing we're going to do is tell it which variables we want to use for each axis. So we're going to do the same thing. We're going to say ggplot, use as a data set, gapminder. And then the argument that we use to specify the axis, it's not as intuitive as data, I have to say. It's called mapping. I guess it maps the data to the plot. And to mapping, we provide this argument AES, and we can write in there x equals, so we're going to start with GDP per cap. Then we're going to do y equals life exp. And once we do that, now we should have axes on our plot, because we've said to ggplot, first we're going to supply this data set, and then for mapping, how we map the data to the plot, we're going to use, AES means aesthetics. It must be, yeah. Again, that's not as easy to follow intuitively as the other one. But anyway, what we always have to do is mapping equals AES. And within the AES argument or function, we provide the X and the Y. I'll just pause there a minute so you can make sure that makes sense, or that's running and you can ask any question if that makes sense. Poetumelo, that means that you haven't run this line, library ggplot2. So maybe you installed the package with this command here, this line here. That like downloads the code in the package to your computer, but it doesn't make it active in your R session. So to make it active in your R session, then you need to run this line, library ggplot2.
I have run the library ggplot. I did it before.
And what does it? Could you post the output of when you run library?
When I run library, it says error library. There's no package called ggplot.
So that's because the library is called ggplot2. So you need to install it called ggplot2 and then library ggplot2.
All right. Yeah, thank you very much.
Excuse me.
Is that working now? Mm-hmm.
Yeah, the one you said, is it mapping is equal to axis? Is it AES?
Yep.
Okay. GDP. Okay. What is that AES?
So AES is short for aesthetic. And okay, so it does kind of make sense. I don't think it's very clear, but the full, so I've just done help AES because I wanted to understand why it's called AES a bit more. And it's short for aesthetic mappings. And that describes how the variables in the data are mapped to the visual properties of geoms, which is part of ggplot. This is, sometimes I don't think people who write computer software can explain things very clearly, but what it's trying to say is AES is just going to tell you what data, how you want to map your data to the plot. And that means first, what's going to be on the X and Y axis. So I guess what you have here is your data, right? You're specifying the data with the data argument, but the data has 6 variables and 1,000 observations, and you don't just want to put all of that on a single plot. So first you supply the data, and then through mapping, you're saying, how do you want the data? How do you want to play with the data and map it visually onto the plot? And so the AES is the aesthetics of how you map the data to the plot. Surely there's a clearer way of them kind of denoting that. I don't know. Anyway, but this, you'll get used to this quickly because we use ggplot a lot. And so this argument is always there. Mapping equals AES. And then you can see in the usage of AES, the main 2 arguments are X and Y. And we'll come back to this later on with more arguments. And so if you run that, now everybody should be able to produce this. Now, again, you might say, where's the plot? But that is because so far, all we've done is specify the data we want to use and what the axes are, the axes. So we've got an X-axis and a Y-axis. And sure enough, here's the GDP per cap and the life expectancy, which is what we've asked for. But actually, we haven't told it what we want to plot yet. Because there's all sorts of things we could put on that axis, I guess. And so that's what we're going to do next. So the next.
Yo, it's telling me you could not find the GG. Is it GG plot?
Mm-hmm.
It's telling me, I don't know whether it was properly installed.
So have you done this line at the top, library ggplot2?
Library GG plot 2. Okay. No. Okay, library GG plot 2. Okay, after installation. Okay.
Now that should. Is that working?
No, I'm coming.
Hello.
Yeah.
I have another error.
It's still
What's
giving
the
me the
error?
same problem.
Oh, let's look at that one.
It's on the chat. Hmm?
Error in fetch key.
Is it due to installation? Is it related to installation?
That one, the first one, I'm a bit concerned about because it looks like installation. The second one is because there is a capital P in GDP per cap. And so it's case sensitive.
Oh, yes, there.
And so that's why, but I hope the first one is going to work still, but I hope the first one will be related to the second one.
Okay, let me
Let me know.
yeah, thanks.
My own is not giving me the. It's saying it couldn't find the GG.
Could you post? Yeah, could you
Lots.
post the output in the? Could you post the code and the output in the chat, and I can see?
Okay.
If anybody, oh no, you can. Yeah. So the next thing for those who have got to this point, you post the error, and I'll have a look for you. For
Yeah.
those who want to go on to the next point, what we can do is add the same layers. It's of course becoming repetitive, but it's to show how we build it up one layer at a time. We're going to do ggplot, data equals gapminder, mapping equals aesthetics, x equals GDP per cap, y equals life exp. So that's going to do the same thing we already have. And now the magic starts happening. And then, so what we've got so far is actually just this single function, ggplot, with quite a few arguments. So it does look a bit more complicated than what we saw earlier, but this is hopefully building up in a clear way, and you can always go back one at a time to see how we've added these points, added these layers sequentially. And at this point, we've got ggplot, we've got the data, we've mapped our X and Y axes, and this is all within one function, which you can run on its own and it will produce something. However, this is what I found really confusing at the start. You can add a plus sign at the end of a ggplot function call. And I think that's the first time we've seen that this week. And it really took me far too long. I'm embarrassed really about how long it took me to figure out, just completely, I was overwhelmed by just like how these things were put together and what it all meant. But actually, now I say it aloud, I don't think it has to be so complicated. So you have your first line, which is specifying the data and the mapping, and that will function on its own to build you an axis and a kind of basic plot. But then you specify how you want to show your data with a separate argument. And that is generally through this geom argument. And there are lots of them. So if you type geom underscore, you will see that there are lots of different types of way that we can visualize our data. And I've hardly used any of these. Most of the time I probably use only 3 or 4. But here we go. Today we're going to use geom point, which is going to display all of our points as individually as little dots. There we go.
Yeah.
And
What do I do?
yep, I'm going to look at that. So that means you haven't loaded the
the thing has been installed, but I don't know whether the location they are talking about, the location I put it or so. I don't know. Maybe it should have been
could you copy and could you run those 2 lines of code in your RStudio and then paste the output into the chat?
which I've pasted it into the chat.
So I've just replied with 2 more lines of code.
Okay.
Install
Okay, I should
packages
run
and
it.
library. And I guess one way of saying this is like when you install packages, that's the equivalent of downloading a program to your computer. That's like downloading, what do we download these days? That's like downloading Microsoft Word or RStudio itself, but it doesn't actually open it, of course, because when you download some software to your computer, you don't really open it, you just download it. So there's a second step required, which will actually open your package.
I think it's installing it. I don't know. Okay, it has finished and said, and okay. Is it one after the other? I will do it, or because it's showing me the library.
Yeah, so after you've done install packages, then you do library, and that should load up into your current R session so you can use all the functions contained in the library.
Maybe I did something bad there.
And remember the library and the library that you need to install is called ggplot2, but the command is just called ggplot. Okay.
Yeah, I did it. It didn't. It just was just giving me the library back.
So for the people for whom this is working, there's a challenge here. Can you guys try and change this plot so that instead of showing the GDP the life expectancy against GDP, can you show us how the life expectancy has changed over time? And the clue is here that you want to show a time variable from the Gapminder data on the x-axis. We'll have a minute to do that, and I'll try and fix Obi's problem. So if anyone can create the time life expectancy over time plot and put it in the chat, that would be great. So Obi, let's where are we at?
I got an information. It's telling me that one or more of the packages to be updated are currently loaded. Restarting R prior to install is highly recommended. R Studio can restart R before installing the requested packages. All work and data will be preserved during restart. Do you want to restart R prior to install? That's the question.
Yeah, I think you would do that.
Okay.
That's great, Trevor. That's right.
Okay.
And then the second part of the challenge on the website is, so I'll just show that here actually. So instead of GDP per cap, we're going to do year, and that's going to show by year. The second question is, now we've got a scatter plot of the life expectancy by year. So yeah, how life expectancy is distributed and changes over time. There's another property of the points that we can change, which is the color of the points. So can you, the next challenge is to modify the code so that the points are colored by continent. And the clue is that the color argument has to be given in the mapping part of ggplot. So who can, yeah. There's so many cool things in here. Okay.
Okay, it has come out with the same. It came out with ggplot data, Gapminder, mapping equals this, else this, y this. It has come up with that and returned to the console. That's when I did it and ran the program, it came back showing it did it.
So you should be able to run the code now by make sure your library, use library to make sure the package is active, and then.
So I should run the program. How do I run it?
So you should have all your code. Do you have all your code in a script at the top still?
Okay, it has come up. The graph has come up.
Great.
So, okay.
I think we're
Yeah.
scheduled. Sorry, this is just a general notice.
And
We're
why is not
scheduled to
expected.
finish now. So if anyone needs to leave, of course, you're very welcome to. This has introduced ggplot. Again, this is very brief. There's lots and lots of cool ways you can suddenly, I mean, there's just such great flexible ways of plotting all this data, and there's all sorts to come in the rest of this. I'm going to stay here and go through for another. I don't want to take up too much more time, so I'll stay. I mean, I'm happy to stay until for another hour at least. But let's say I'm going to continue with this for half an hour. And if you want to stay and follow along, then you're very welcome to. But just to highlight, we are scheduled to finish at 3. So if anyone wants to leave, that's absolutely fine. And we'll be back tomorrow at 9 for some more. But in the meantime, we'll just try and get through a few more graphs. What I love about this is like you've seen now we had just the first one that is just the data, and then you tell it how you want the axes to look. And then suddenly you explode so quickly to the different. In fact, I've missed out a step here. So first, then you can quickly add the points, and already it looks like a cool graph, and there's loads you could take from that, and you can change variables so easily, and you can play with all sorts of parameters. But then you can start adding, so much information to this so quickly. Beside the variables on the axis, what can and cannot be included in their mapping? Excellent question. So I think Trevor, let's go through a few more of the graphs that we can do, and it will start to capture some more of the flexibility. If you wanted specifically to look in AES, then you can help AES, and there will be, because you can do like loads of colors and shapes and things like that. But actually, oh, it's not listed there. A lot of the fine tuning also comes with separate. So here, so far, what we've got is the basic ggplot function that sets out the axes and how we're going to how we specify the data, and then there's GOnPoint here, but there's also you can build in more layers with all sorts of things. So for example, there's one that's called labs, and this allows you to set a title. All right, I'm just doing this quickly to show that you can add layers, but we're going to build a couple more interesting cool ones on, and hopefully that will start to show you how we can get more and more into this. And again, like I think that's a great question, and it really gets to why I like this, is there's so much flexibility and so much detail you can very quickly provide. So if you like that, then for sure go on as far as you want with this exercise. And there's websites with just cool ggplot kind of not showcases, just people sharing cool ggplot functionality because I really think they can be pretty. And if you find that interesting, then have a look at that as well. So what we're going to do quickly here is
I
just
have a challenge.
yeah.
After the first one I did with stopped at the life the Y, then the second one I had the geometric point that's including the color equals to continent.
Yeah.
It gave me said geometric point colon NA dot RM equals to false. Static.
Could you post it into the chat?
It's
hard
okay.
Because it's hard to follow with
to grasp. Yeah, okay, let me send it to you.
So I'm just following along on the window. Hopefully that's the same thing or not. I'm just oh yeah. Okay, so what you need to connect that is a plus sign after the first function.
Okay, at the end of at the end of continent.
Yes, after the closed brackets, then you need a plus to connect. So this is it's a good example of how ggplot works. It's linking all of these functions, all of these lines together in a single plot. And so that's why you have this plus sign that links them together. So what
Okay.
we've seen so far is how you can do that with just a point. So this is like a classic scatter plot with each point having an X and a Y value. But as I said before, there are loads of things we can do. And so the next example it gives is to show everything as a line. But actually I looked at this the other day and I actually can't even figure out what's happening here. What is it?
Yeah, it came out fine.
Great. So keep coming, keep coming. So what's happening here is we're colored by continent. The color on the graph is by continent, but actually, I guess you can't really have, it's to do with having a line, one line connecting multiple points from each time point, something like that. It's kind of weird looking. But what we can very happily add now, so this is partly to show again the flexibility here, is that we could separate the lines by country. And so there's this extra mapping argument we have called group. And here it could be by country. And so what we're going to do here is at the moment we have multiple countries per continent. And so drawing a single line to represent all that data doesn't really make sense. So we're adding an extra mapping argument that says group by country. So still the lines are going to be colored by continent, but then now there's going to be a separate line for each country. And so, yeah, the color still separates by continent, but it makes sense. It didn't make sense to have a single line per continent. It does make more sense with a single line per country. And again, I like already considering how I know this code it kind of looks quite complicated at the start, but having built it up and just doing it one step at a time, I feel like this is a pretty efficient way of building so much complexity into, getting so much information out of this data set. Okay, so just to demonstrate then, now we've had geom line and we've had geom point. Let's see what the points look like. Well, actually, I don't know if this will make sense to do with that. No, it doesn't, because yeah, okay. So we're going to have geom line. But the other thing is we can combine these geoms. So remember, geoms are just layers to the graph of ways of visualizing that. Yeah, different layers of actually visualizing the data rather than building the plot basics. And so we can add the points on as well. I guess here it's very crowded, but if you didn't have so many lines and points, you might want to be able to see how the actual points themselves. But really, I think that's just to show how you can. So yeah, really that's just to show how you can combine different parts of the plot. Cool, there's another one where you change the color, but I don't think we want to do that immediately. One thing is you can also, no, I don't think I'm going to say that. Okay, so we're going to do something else now. So this is to show so far the kind of fundamentals of how we build plots through layers. Does anyone, what questions are there about so far about combining the layers to build up a plot like that? Does anyone else think this cool? Or I never realized that I thought this was so cool until now I'm describing it and I'm getting excited.
I'm here. I'm here.
Is it working?
Transformation. Yes, the ones I've done has worked the way it is here.
Lovely.
I'm just following what you are doing and I'm doing it and it's working.
Great. So we're going to make the first plot we did again, where we have the life expectancy and the GDP per capita. So we're going to build it in the same way. We have our data argument. That's a good question, Trevor. What are the more powerful ones? I think this is definitely the most popular one. I'm sure there are people who have other preferences. You know, I don't even know what the second most popular one would be. I've used exclusively ggplot for almost 10 years. Oh, look. So here's a link. There are other ones. Be interesting to know what. Oh, yeah, I have heard of. So in the end, it becomes, say, a kind of ecosystem of plotting packages. So just having a quick look at this. There are other ones. So Plotly I've seen before, and Patchwork, but they kind of interact with ggplot and each other, I guess, to build functionality between them as well. So you could just do so much with this in the end. And then going further down, there are kind of even more detailed things or other libraries that have even more detailed function that allow you, I guess the point is they allow you even more control over the fine details. I think, yeah, I agree. ggplot is super versatile. I mean, in the end, there will always be some perfect thing you want to do, some tiny detail that ggplot doesn't allow, but there's a good chance someone else has had that problem and they do want to, and they've published code to do that. But it's a great question, and I guess I'm excited about ggplot too, but I also I'm completely open to other ones being just as exciting. I think it's just the flexibility that comes with this coding approach and having a nice platform for doing it. But for sure, there might be other good ones that are even better, and I'm open to that. All right, we just showed this example of a different type of kind of flexibility we can have. Was it this? So we go back to this one. Well, I mean, great. We've already can see some information from here. It's kind of a neat enough looking plot, and we haven't had to work very hard to put all that data really neatly together. But the distribution of the plot is kind of weird in the sense that most of the values are close to the y-axis, so that they have low x values, and there's quite a lot of outliers over here. So the overall pattern is a little bit hard to see. And one of the ways we might be able to improve that is by plotting the log of the x value, which has a kind of, yeah, which might help make this relationship more linear. And this is a kind of exponential with a different, I don't know how you describe it. So what we're going to do is we're going to add an extra layer to our plot. So again, this is with this plus sign, we're going to be able to add an extra layer, an extra function. And this, by adding this scale x log 10, it's basically going to log 10, take the log 10 of every x value and recreate the plot. And now we can see that there's a more linear relationship and it's just easier to kind of figure out what's going on. I think this demonstrates that, I mean, just the ease, right, that you can transform the data and recreate the plot, as opposed to you might have to go back to your raw data, find out the calculation for changing for calculating the log 10 value for converting to log 10, and then you would have to remake the plot, select the new column, and remake the axes and all of that kind of thing. But here you just had this very simple one line of code, 20 characters, and then it will do that for you. Of course, if you want to remove it again, it's just as easy to do that. Okay, so now we've got this this more linear relationship that we can see between our X and Y value, we might want to know, you know, what actually is the relationship. Where would be the best line to draw that? What if you were to draw the kind of line of best fit, where would it go? How steep is it? And how much noise is there around that? So we can also add kind of, I guess, stats. I guess it's, what would you call it? So I guess this is, so now we're going to build up our plot again. I hope that by now this is clear how we build up our plot every time. So I'm just doing exactly the same. I'm typing out, you could copy and paste this. I'm just doing it to really show how we build the plots one at a time. But yep, so then we're going to have our geom point, and the geom point is what plots every single value as a point on there. And then we're going to scale x log 10. And have that. So here's, I mean, this is an amazing, powerful thing as well. There's an argument called geom smooth. And I can't remember what the default setting is. So, okay, so the default of this is to plot, I think it's called a lowest line. It probably, that. Maybe we're using this. Anyway, so it's doing some kind of calculation to estimate the relationship between the X and Y at different points. And what we can do is we can supply this argument method equals LM, and it's going to fit for you a linear model which has this formula Y by X. And so behind the scenes, as well as creating the plot and plotting the data points and transforming the X value, it's going to fit a linear model to your data. And then it will plot you this line that represents the coefficient of the, I guess, the X coefficient. And then the little tiny gray area around that is some measure of the dispersion. So that will be like the standard error most likely. And I also use this quite a lot because sometimes, I mean, I guess this is quite a good point here, that although it usefully captures that there is clearly quite a strong positive line here, but it also represents, I think it's quite noisy. And so I don't know, I just like having both those pieces of information. There is a relationship, it is strong. The standard error is relatively narrow. By just looking at all the points, I think I would say that it's quite noisy. So already we're building in so much information so quickly into our plot. We can control that, the width of that,
Is that
if we want.
sorry? Is the last one you wrote Joe Smooth with the vector method is equals to 1? Is it 1 meter?
No, LM. That's a
LM,
these L's
okay.
and ones are really confusing, aren't they? Who writes an L with a tick at the top?
Yeah,
It was
okay.
the same in the bash day, wasn't it? It looked like a 1.
What
This
does
is
it
an L
mean?
for linear
L?
model.
Okay,
It
linear.
means it's L for linear model. So what? Because what you can do here is we're asking for ggplot to fit a straight line through the data and to do the calculations around that. Whereas there are different types of lines you can fit. The other ones were lowest, which is like locally estimated something, and a general additive models. Different types of lines you can fit through the data.
Okay.
I've whizzed through those last ones because I feel like you can just kind of, I feel like it's more intuitive watching these plots be built one at a time, and I haven't paused because I hope it was easy enough to follow. I will pause now, but there's one more thing I might show if we have time. But what questions or feedback do you have about that? Trevor said there must be a way of changing the font. That's definitely true. You know, you can definitely play with the text size and the spacing and the positions and all sorts of details. And it's really flexible for that. Well, no, I mean, you must be able to change the actual font too. Oh yeah. So there's this argument called oh, look at that. You could do it for everything. Yes, that's true too.
Oh, what are
Yeah,
we
try
doing
that.
here now?
We're just looking at how you can play with the options in R, the text. We're just talking about how you can really customize all sorts of details in this, I guess. There's one other part of the tutorial that I would show, maybe two. So I'm going to do them quickly, reasonably quickly now, between now and in the next 5 to 10 minutes, and then yeah, we can take final questions and close.
So where do we
There
get
are
the
loads.
option from?
Sorry, say that again.
Where do we get the option from? Where you were trying to check on the appearance of the graph. What you
So
were
you can
just
do
doing?
tools,
Okay,
and
on tool.
in the top.
Okay. To is it project option?
Yeah, tools, global options.
No, tools. Okay, global option. So what are we going to do on it? Then click on
We were just
appearance.
talking about how you could change the font we were talking
The
about.
font. Okay.
Okay. So one thing we're going to show quickly here is how you can make multi-panel plots. And that's because sometimes, right, two things are happening here. In this plot, that's too complicated, isn't it? I mean, it gives you a general trend, an idea that the life expectancy is going up and there's some variation and stuff, but you can't really get into any detail, for example, by country. So the first thing we're going to do is edit this data input. So this is flexible, of course, too. And we can practice some subsetting here, as we looked at before. So to make it more manageable, instead of plotting all 1,704 rows from I don't know how many unique countries, we're going to take only the countries that are in the Americas. So if you remember, one of the ways, maybe we didn't look at this, but one of the ways we can subset data frames, actually this is now looking like an oversight that we didn't look at this earlier. One of the ways we can subset data frames is using syntax like this. So you have gapminder, and remember our square brackets are telling it that we want to subset the data frame. And what we're saying now, so of course we have our comma in the middle, and on this side are the columns. That means because it's blank, we want all of the columns. And on this side of the comma, we have the logic for filtering the rows. And so what we're saying is we want to look at gapminder, and remember $ tells you which variable you're looking at. So we want to go in gapminder, look for the continent column, and we want to know all of the rows where the continent is equal to Americas. So I'm going to execute that quickly here on its own. So I've highlighted just that logic, and it's going to print for each row whether the continent value is equal to Americas or not. This is a bit of a detour, but this is explaining how we're going to subset our main data frame to make it a more manageable plot. So we're going to, with this, by kind of having this logic question or statement here, we get this vector of true false values. And now we can use that to subset the rows in gapminder. So that's kind of technically what's happening. Functionally, what's happening is you're just now subsetting gapminder for only rows that come from the Americas. And so, of course, now you can just show the subsetted data frame, and all of the continent is Americas. And so we can use this data as the argument for data when we're starting our plot. And this is to show that it will make the graph more manageable, because we've only now selected, I don't know, 10 or so countries. Okay, so this is to remind you that without that subsetting, we have every country and it's like pretty jumbled and hard to see. Then we add this filtering in, and that subsets, and then we have a more manageable plot. Okay. The last thing we're going to look at in terms of plotting is how we can make this into multiple panels. So instead of labeling each line, which they'd still overlap quite a lot and it might still be a bit tricky, we might want to have a separate panel for each country, but still have all of that shown on a single plot. So I'm opening my panel in anticipation of a big explosion. So what we're going to do is facet wrap that. Okay, hold on, that was too fast. So what we're going to do is we have our plot that shows each line on the same graph, and then we're doing this plus sign again to tell ggplot be ready. We're going to add a new function, a new layer to our plot, and this time we're going to call it facet wrap. Again, I don't really understand why it's called facet wrap. But anyway, all we need to know is that it's going to split the plot into lots of different mini plots. Each mini plot will contain data and we can tell it what to put in each kind of mini panel, mini plot using this argument here. And this is a tilde, so this is not a minus sign or anything. That's the kind of squiggly line tilde, which I'll put in there. And we're saying now, take this plot, and instead of putting all of the lines on a single big plot, break it into many smaller panels, and in each of the panels show one country. And this is super useful because there are often times when relationships overall in your whole data set might look a certain way, but you know there's so much variation from group to group that it's worth separating them out. And when I was working with the naked mole rats, I was looking at 8 colonies, and you'd see so many kind of I was looking at behavior, so many general behavioral trends. But if you'd look at individual colonies, they'd all be completely different. And so it was useful for us to be able to say, look, overall, we know that weight is related to behavior, but if you look within each colony, it's a complete mess because there's so many colony specifics and individual specific dynamics happening that it's hard to make generalizations. Or you should make the generalizations with the caveat there's a lot of group level variation or something like that. So again, I think this is like with just a single line of code, facet wrap, which again I don't find particularly intuitive, but this adds so much flexibility, right? That's such a great function that if you want to plot by any grouping factor, and of course we've actually subsetted only for the Americas, but if we hadn't subsetted by the Americas, so sorry, I'm rushing a bit again here.
Sorry, what after putting the Americas, is it is it comma also that you added at the end?
Mm-hmm.
Because I don't know why my own is giving me an error sign. Maybe the double sign equals. Let me try it again.
Mm.
Wow.
If you put it in the chat, then I'll have a look.
Okay. Yeah, I think it's better now. I think I didn't put the double sign of equal. You understand?
Can you, if you put your code and the output in the chat, then I can have a look.
It's been taken care of.
Have you fixed it?
Yes, I think I didn't
Excellent.
put the double sign of equals before Americas. That's where the problem was.
Yeah, you need the double. Yeah.
Yeah.
Okay,
So
there's one really, I promise
assets
this is
that
the last thing we're going to show
Okay.
today. I promise, and then we can go. So again, so far what we've done with this is just show the plot in this panel on the right. Then there's this plots tab, and we can show lots and lots of plots here, which is great. But actually, we might want to save this plot. So if we might not want to remake it every time we want to look at it, and we actually might want to save it to file too. So here we can, as we've been doing before, we can make this plot into an object rather than just showing up here. We can then use this line of code. Can you see I've added here life expectancy plot and the assigning arrow that we've used many times. And hopefully now this is going to become a plot in here. So I'm looking at it. Oh yeah, so that's worked, and we have a plot over here, and we can check if that's worked by doing, we can just bring it up as an object here, and it will show it in there. And the final thing here is once you've saved it as an object, oops, that's not it. You can use this function called ggSave.
Pardon? Once we saved.
So once you've stored your object as a plot within your R session, you can then save it as an actual file on your computer with this simple command. Right, then that really is the last of the day. So yeah, so instead of just running this part of the code, which will show your code in the panel here, you can add this assignment thing that we've been doing lots and lots of practice with, and that will create a life expectancy plot in your environment. So that means it's kind of stored in your session. And so you'll be able to reference that at any point by just running this, which is like showing a data frame, for example, which would show up here. But by running that, you show it here. And then ggSave has this function called ggplot has a function called ggSave, and the file name you just give it a string, and if you just give it a file name, it will save it in your current working directory. Wow. And does that. So here it is here. It would actually be better to do. Right. I know that was a bit fast again, but I think the nice thing about plots is that they're more intuitive than the rest of the stuff because you can see them. And when you say, look, this does this, ping, and it plots up with a new line or different colors, then it's immediately understandable what that means. So although that was fast, I hope it was as followable as possible. And I hope we've started to capture some of the potential uses of both. It's both ggplot and R, which are really cool, but this is the benefit of a coding type approach to making plots, as opposed to an Excel approach where everything is done with more selecting data and it's a bit more clunky. Once you kind of get comfortable with this, which is a pretty good priority, I would say, a pretty good thing to become flexible with. You really quite quickly can build all sorts of nice plots quickly, flexibly, save them to file, share them with colleagues, save them for later, and yeah. Right, sorry, we've gone over again. It's 3:30.
Please,
And I know.
please,
Yeah, of
please
course.
don't move. Please, I'm still saving. Sorry, I'm still saving. Please.
Yeah, well, I'm not in any rush to leave. I'm just conscious that we said we'd finish at 3. If anyone wants to stay and ask questions or go through anything, I'm very happy to discuss. We've missed loads of challenges throughout the day today as we try and catch up some time. So there's plenty more fun to be had trying to figure that stuff out. Yeah, so yeah, if you want to leave, then of course, thank you for staying right to the end. I hope that's been useful. Thanks for your comments and questions. And yeah, what questions do people have before we sign off today? Questions or comments? Okay, if nothing major, then as I said, I'm going to be around for a bit longer. Please feel free to stick around and chat or ask any questions about this or anything really that we've touched on in the last few days. Otherwise, yeah, I will see you tomorrow. We'll pick up again at 9. There's one more section that we were supposed to cover today, but maybe we'll do that tomorrow, or maybe we'll move on. I'll contact the guys and see what they want to do. Cool. All right. Yeah. Thank you, everyone. I hope you found that useful, and see you all tomorrow, hopefully.
Yeah. Not to Richard direct. Hello. I think the ESCOM meeting will be on this line. Sorry, yeah, please. I'm in a meeting. I'm going off. Please, I'm in a meeting.
James, if I may ask, the command saved a PNG into
Yeah.
the. Okay, let's go.
Has it worked?
Yes, it worked. I can see the PNG.
Because then what would be really neat and tidy is if we had a. So I'm starting actually, I've been a bit naughty here, building up all this stuff in the main folder. But what's really neat is if you have a results folder, and in the results you have a named plot. I think it's amazing. You can go from your data set to a PNG, nice professional looking plot that you can share with colleagues really quickly right now. You share that with anyone, put it in a document, send it in an email.
And it's easy to handle a PNG. You can also send on a WhatsApp.
Exactly, the flexible formats as well.
So how often is it used, or do you use it in biology side every day?
GG, like plotting and ggplot. I use all my plots out of ggplot. Yeah, everything, at least with the R, everything that's done in R, I would do exclusively in ggplot. I think you can make nice plots, like, publication ready plots without much more than what we've done today. You'd probably tidy them up a little bit more, but you don't need loads more. And you can see how quickly you can do that. And if you have 10 variables, it's very easy to make a function that will create a plot for each of them. And yeah, you can, as you said, you can export as a PNG, which is you can then do some, if you want to add some random finishing touches in an Illustrator, you can do that. So I think it's flexible. I think it's efficient and will quickly take you from data to really nice plot.
Yeah. So the compared to Excel, this is better only because it also does coding. Am I getting it right?
I think that there's having a kind of code and script-based way of doing it has a few key advantages over Excel in some of the things we've touched on. So, for example, if I wanted to go up and if I wasn't sure, when I made that plot, had I already filtered to remove 1970s or had I included 1970s? Well, if you have that in Excel, you just have the plot and you don't know, you can't go backwards, and figure out what you did. Whereas here, you know for sure, you just go back. At what point did I make the plot? Did you filter the data out here or not? And you can run this code again straight away and it will tell you whether you've done it, whether you know exactly how you got to the endpoint. So it's really clear your work history. And of course, that means if you want to redo anything, because for example, you deleted the file or you thought you weren't going to use the file, you deleted it. There's no long manual work to copy and paste, possibly introducing errors by doing all the manual copying and pasting and so on. You would just really go to the top of this script and go all the way through, click, 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 click. In fact, you could run the whole thing. You can select the whole and it will run. And there are some extra benefits that come with that. Like if you wanted to use a different data set, say they released a more recent data set than this, you wouldn't have to do any of the like manual processing steps again. You would just literally replace the file name here, and assuming it was the same format and you wanted to do the same thing, again, you just click the whole thing through and it will update the output.
Are you done with him?
Yes.
I posted something on the chat for James. My own is giving me an error sign. Object live as
that looks great. That looks great though. You're really you're right at the end of what we've done, and I think it's going to work. There's just one reason that it's not working at the moment. What's happening is, so you have this multi-line kind of function, don't you, at the moment to create the plot? and at the end you're trying to show the plot with life expectancy plot, but before that there's a plus. So basically, when
Yeah.
you're trying to make the plot, you're also
Okay.
trying to include that plot, but it's not been created yet. So the plus sign after geom line can't be there. They have to be
Okay.
separate.
So I should, let me rerun it again. Yeah, these things are so sensitive.
Yeah, it's
There's
true.
still an error. Results of, is there any comma at the end before the final one? That's
Can you share
live.
it? Can you share it again in the chat?
Okay. That at the end of PNG, any comma or so sensitive.
So I think that should work. Oh no, hold on. So then we have got as far as. So I think does it show the plot itself? If you do life x dash plot, does it show the plot in the panel?
Yeah, it just showed the scattered plots, not the ones with not the
True.
smooth one with the scaling and the names also. But it shows
Okay. Okay, we can fix that easily enough. So there's a couple of things we need to do. If you look at my screen, then what we have
the
is
file name is missing. The name I gave it is plot.r. I don't know whether it didn't accept it or we gave it a plot as life expectancy plot. I don't know whether.
So you're very close. You're very close to being there. So what's happening? What you need to do for GG save is you need to provide two arguments. Can you see on my screen? In
Let me
fact, I'll
check.
share it in the chat as well.
Yeah, you
So you
say file
basically,
name.
yeah, there's a file name argument and a plot argument. And so you need to, inside the brackets after GG save. So I can see that you see on in your code, the second bracket is on the first line. And so at the moment, you're not telling GG plot what plot to include. So that second bracket needs to come at the end of the second line.
Let me get it. Okay, after GG plot bracket opens, then file name is equal to result plus dash this. Then any comma there at the end of, that's your own.
Yeah, because
Okay,
so basically,
okay,
yeah.
I put a comma instead of, I put a bracket instead of a comma.
Mhm. And so that bracket needs to be a comma, and then you need to add the bracket on to the end of the second line.
Of the last line, Okay, thank you.
And then so you're going to tell it the plot is life expectancy plot. There's one more thing, which is that you have in the first thing inside the bracket is plot.r, but here it should say file name.
It should be my file name.
No, it needs to be the word file name, because you're saying to GG save, here is you need to write the word file name equals, because you're telling it after this, whatever comes after this is going to be the file name. Do you see what I mean? You need to you need to match up the name of the file with the right argument for the ggplot function.
Okay, so
And
let me try. Let me try it again and see whether I will get it. Yeah, I saved.
Very nice.
Saving it.
James,
Do you know how
Thank you very
you
much.
can have a code editor or code editor in Python? Is it available for R?
For Python,
Yeah, I was making example of Python. There's a code editor, or can I say AI editor? Not.
yeah, I mean it's a good question. So I've used R for a long time, and I only recently, like 1 year and a bit ago, I started learning Python. And R Studio that I'm working in here, I think everybody's probably working in R Studio, is such a nice place to work, I guess, to work and write your code. And I was a bit spoiled because I didn't understand how good it is. In terms of like you have your code here, your outputs are in the console, your objects here, and then your plots and everything, your files can be here. And Python doesn't have, as far as I can see, it doesn't have such a natural platform for running code. I think a lot of people use Jupyter notebooks, and I use or Visual Studio Code for Python, and I use a combination of Jupyter notebooks and Visual Studio Code. I use Visual Studio Code more in the same way that I use RStudio though, because that you can see your files, you can see your code, you can see the output. So I use Visual Studio Code. I think that's pretty cool.
So the
Somebody,
Jupyter does edit. I mean, when there's an error, does it highlight it?
Yeah, and you can
For
run all of your
example.
code in a kind of in a console type. It's like it kind of is like having a terminal really, or a console. Visual Studio. In fact, do you want me to show you quickly?
Yeah, it's cool.
I'll just be very quick.
after I will have your attention.
Yeah,
When you finish
I'll
with
just show
me,
very quickly my screen to do this. I'll be like just 1 minute to see if, because I think it's quite an important decision actually if you're going to use Python. It's or another way of saying it is that with R, it's quite clear how you're gonna. It's quite clear where you're going to run your code, but with Python it's less clear. So here we go. We're going to stop sharing that one. We're going to share a different one. Visual Studio Code. So you should see my Visual Studio Code window now.
I do.
And it's the big black screen. I'm just loading up the various bits. And so here on the left-hand side is like a project folder with all the files. And I have some code here. Right, the main one is this one is called main. And so now it starts to look a bit more like R. So I just need to do them. Yeah. So we have our kind of main code in this file here, which is just like the R script we had. You see that we've been working from an R script today.
Yeah.
And here is the files that we can view. It's not quite a global environment. There's no environment thing here like R has, which I find really helpful to know.
Oh, yeah.
I've loaded in a data frame. How many rows does it have? Or, just to check, has it actually loaded? Is it the right data frame that I'm expecting? And that is a little bit frustrating. But then, so what you can do is, this is just a terminal like we were working with on the first day. And within that, I can type Python, and then this opens a kind of Python. I don't know what you would type. This opens effectively like a console. In R, we're working in that kind of console space.
Yeah.
And so here, this is like loading libraries in Python. You can, maybe you've seen this before and I don't need to show this, but I found it would have helped me a lot if someone had shown me at the start how this all works. It took me ages to, like weeks, honestly, to figure out. I think that says more about me than the system, but it took me a while to get going. And so you can copy and paste like we would in R, you can run things directly into the console, or you can highlight things, and there's a run button up here, I guess. Run Python file. And so there's a
Oh.
shortcut I'm using here, and it will run my code one line at a time. So this kind of acts a bit like what R is doing. Do you see what I mean with the code, the console, and then the
Yeah.
files shown here? If you break something, you'll get an error message, and yeah, so it covers some of the functionality, but I don't think it's as neat as RStudio. That would be my assessment.
Yeah, I think so too.
Okay.
Let's
Can I
think.
ask the question? James, I posted something there on the
Mhm.
chat, and it was giving me a
Mhm.
warning that that's in directory create result, that's result already exists. So I don't
Yes,
know
yes.
I don't know why that's warning. And it's
Yeah,
still
well, I
saving.
think
I don't know whether it has finished saving. Secondly,
this is a rare warning or error message that is very clear and direct. So it is telling you that the results so this thing called directory create is trying to create a folder called results. And then the warning message is telling you results already exists. So we can do some kind of reverse, we can do some troubleshooting here. What do you think it's telling you?
yeah, that's why I don't know how to resolve it.
So what do you think it's telling you? If you're trying to create a directory called results, and it
Then I
says
should change
results
it to another.
already exist,
I can put it, make it result B. Huh?
you could, that would make another directory called results. But as a warning message, it's just, so one is that it's not an error, it's just a warning. A warning is like a lower grade of an error. And it's just telling
Yeah.
you that the results directory already exists. So you're trying to make a folder and it already exists. So it's just telling you a warning in case you weren't aware. But
Okay. I
it's not
can.
actually a problem. And the reason that you know it's not a big problem is because when you've tried to do gg save and then in your file png is going in the results directory, at the bottom it says saving 5.6 times 4.52. That's the dimensions of the image, the file you're saving. And because it's saying saving that in those dimensions, we know that it's saved. Do you see what I mean?
Okay. That which means okay, I have other results and I have this one that is an image. Is that it? Can
Yeah,
I don't know.
you have
Will it
a
override?
well, it just says you have a folder called results that already exists, and we're happy about that because that's where we want to save. And then the image itself looks like it's been saved. So now you can go in whatever the name is of the little tool that allows you to explore your files. It's like File Explorer or System Explorer or something like that. And you can navigate to the results folder, and inside that results folder should be the plot saved as a PNG file.
Okay. Another question is that all the things we've been plotting since, were they only, is it only the last one that will be saved in that image or all of them?
Just the last one. So the second argument, well, it's not the last one, but here's the argument is called plot equals life expectancy plot. So you're actually saying in the gg save argument function, you're actually being very specific about which plot you want to
Which one
save.
to save?
And you're
Okay.
of course that you could save any plot in in fact in the script, I would advise that you save all of your important plots as you go.
Okay, let me see how it. I have yeah. Yeah, he gave me the scattered one. It's okay. But he didn't give me countries. I put country there. I didn't put the countries.
Yeah, so what you need to do for that is you're missing one line at the end of your code. So what you've done by country is each line is now a country. showing the change by year, but there's one line missing from the code, which goes after geom line. So you need to add plus facet wrap. And so this facet wrap line is actually that's the line that tells it to split the plot into different panels and to do one country per panel.
Which one? Did we do that?
I just put in the chat how you do that.
Okay. Yeah,
So that goes on the end of.
We did it. We did that one before. Let me check it. Okay, at the end. Okay. Then I put the lines after I put plus, then I put it. How did I do that? First.
Bye everyone. Have a good evening.
And see what happened.
See you tomorrow.
I know I cut it off somehow. It was a mistake. Yeah, it has given me the correct something I needed. It still gave me the same problem, but the same warning, but it's okay. I now know why it's like that. Yeah, it has changed with countries. Okay. Thank you, James. See you next.
Is that working?
Yeah, it came out fine now. It came out with the countries. Life expectant plots.png.
Well done, Obi, I think. I think you've done well, Obi. That means you've, considering when was it? Yesterday we spent all that time installing the software, our studio. Now here we are one day later and everything's working. You're up to date. You've loaded the data, you've done some filtering, subsetting, and you've made an amazing plot and saved it. But like this is pretty good. It's been a good 2 days, I think.
Thank you
Well,
very
3 days, but especially.
Yes.
You're welcome.
I'm very grateful. You know, another plot I really wanted was this, you know, plotting different, that was what I missed last in May when we did this course it was plotting the regression, standard deviation for you to analyze some data, you know. So I missed it badly, and because of almost the same thing, then there was nobody that could help me out.
Well, if you look on, I'll share the link again. Do you mean it was one of the plots that was made in the lesson? Or was it
Yeah,
separate
that was
question?
the main core lesson. Like today, we did it only 3 days. That was the main core plot we did that day. And throughout that day, I couldn't follow them because the lady was using Colab. And I was on Linux here. I couldn't cope. Yeah.
Well, you look at the so I just shared the link today to all the plots we did, and one of them includes a linear model straight line. I think it's really cool that you can immediately do that. So maybe have a look at that. And yeah, if you have any questions about it, you can ask me either probably tomorrow, I guess now.
Okay, thank you very much.
But yeah, have a look at that link and hopefully that.
Yeah, checking it. Yeah. Creating public linear graph. Okay.
Oh.
Yeah.
Okay, I'm gonna go.
Okay.
Oh, I need to finish some bits of work before tomorrow. I hope that was useful. I think you've made really good progress. Are you happy with that? with the progress. See you tomorrow.